All right. Oh, um, we have gathered quite a lot of people again today. Welcome. This is the second day of the Secom MCP Seminar. I will try to be the chair today, like Thomas did on the first day. Thank you, Thomas, for that. I hope I'll be equally good, although I doubt that. My name is Nikolaos Vastardis. I am a principal engineer with the GLA Research and Development Department, Directorate, in the UK. And I've been working with the MCP and the MCP consortium for a few years now. I want to welcome you all to the second day. And just to mention that this session is also recorded like the one yesterday for reference. I hope everybody is okay with that. Feel free to raise any objections. I don't see any. Can I confirm that everybody sees me okay and can hear me okay?
You're perfect.
Yes.
All right. So in that case, I will try to share my presentation then, the first presentation of the day. We can get going because we have a lot of things to cover and not a lot of time. Let me know if you can actually see my screen.
Yes.
Perfect. All right. So, as I said, my name is Nikolaos Vastardis. I'll be the chair today, but also I'm the first presenter. And we will cover the second part of the introduction to Secom, Secom 2. This is not the version, this is the second part. But we will also cover the fact that there's two versions of Secom, or at least the second one is being drafted as we speak. And we'll see some of the differences. Generally, today is going to be a much more technical session. So feel free to ask questions or interrupt. It's not, I would like this to be a bit more interactive rather than just a push of information. But there will be, it will be a much deeper dive to how things work, how we develop our services, what kind of questions we have, what kind of issues we have encountered as well. But before we go there, I want to have an overview of my presentation first. So we're going to cover a bit the context of Secom and a bit of a refresher from yesterday's excellent presentation by Ramin. Then I'm going to introduce some of the Secom interfaces, as many as I can, as long as we have the time. I'm going to identify some important data structures that I think they're good for people who deal with Secom to be aware of. And I'm going to introduce a couple of tools that we have built, like the Secom library and the XML binding repo that has been accepted now by the IHO NIPWIC group recently. That these might be useful if you're planning to work with Secom and the MCP in the future. So what is, again, Secom? Bit of a refresher from yesterday. As Ramin said, it's a definition of Secom is it's a secure communication standard between ship and shore that provides the standards for secure data exchange with the technical services. Now, I think Gareth, my colleague yesterday, also mentioned that we're planning to use Secom also between shore and shore communications. As GRAD, this is a proposal for the GLA, but at its design, it's a ship-to-shore communication for essentially X100. So it specifies a sort of service interfaces. That's the main bit of Secom. It standardized the communication interfaces for the data exchange, but also introduces some data protection measures in the security aspect. But we also have the concept of the service discoverability, how these interfaces can be discovered by other services, consumers, or even producers of information, and interact with them. Now, Secom is designed specifically for S100. That's its main focus on the payload, but it is payload agnostic, and any other format can be supported, digital format. And it's effectively, the operation is independent of what type is exchanged. Moving on with the architecture, this is a diagram taken from the actual standard, but it's very similar to the one that Ramin also presented yesterday. Effectively, it shows you that you have the S100 on the one side, so the data production. Again, Secom is payload agnostic, but it's mainly S100 that's going to be delivered through Secom, or Secom aspires to. And on the other side, we have the ship side communications section. So we have the ship, VDES, where the last mile exists, and we have the vendor API specific operations. But Secom is in the middle, is in between. You see the central part. So we have the interfaces to standardize the communication between the production and the consumption of the information. And we also have the sections of the discoverability, the service registry, and also the identity registry, the provision of the digital identities, and how to secure the information end to end, which is the red arrow across the architecture. So effectively, Secom just standardizes the communication. It doesn't deal with the nitty-gritty of how that will be delivered in the final steps. So what does it offer us? It offers a set of operations effectively. So we have the service operations, such as to get the summary of what information is available, to get the actual information. It allows for subscriptions to exist. It also supports large data transfers. But we have a second part of operations that deals with the security, the PKI, the public key infrastructure, where Secom can provide the CSR, the certificate status. It allows for management of the certificates. You can get the public key or revoke it, or revoke a certificate, or ask for revocation, and so on. So it defines some part of that operation as well. And finally, we have the search service operations, where basically you can implement the discoverability aspect of it. I'm not going to go through all of these because some of them are fairly high level. Search service is one of them, for example. I'm going to focus mainly on the Secom service operations. But the Secom standard includes all. So if you want to implement it fully, you will have to, or you can take advantage of all of them. Moving to the service operations, I'm going to now drill down to some of them, some of the most important ones that I've worked with at least. And we start with the get summary. This interface effectively allows Secom clients to query and identify what kind of information is made available by a service. So we're talking now about actually how Secom is implemented now. So this is effectively a REST interface implemented as a get operation in REST. And it allows for certain search filters. So there was a question yesterday of how we can actually get only the information we want through Secom. We don't want all the data sets, all the everything that a service has to offer. We want specific piece of information on a geometry, on a specific time frame, or so on. And this is effectively how it's done. So there's a set of search filters that are implemented as query parameters on the REST interface. And they allow for searching based on a container type. I'm going to explain what that is in a moment. On the data product type, whether you're looking for S124 navigational warnings, or S125 it's navigation information, S101 charts, and so on. The data product version, so potentially a service could support multiple versions of a data product. So you can ask the data product the information based on the version you support. Very importantly, based on a geometry. So, for example, if you're planning a route or a trip, you can ask from a service only the data sets that you are interested in that are directly affected due to your route. There is a UN low-code field. It's not very much in use, at least in the implementation I've seen currently. I think the primary use of this is potentially ports or other land-based locations, but it is there if you want to use it. There is a validity time duration field, effectively a start and the end time of the validity of a data set. So you can query for data sets that are going to be valid, let's say, until a certain point in the future. And there's also some pagination details that you can ask. So you can ask for like the first 10 results or first 100 results that are suitable. In terms of the container type, there is a question on how we're going to package the information inside the Secom response. There's two main ways, especially in S100, you have the pure data set, which is most frequently XML based, but this is not the way ECDIS works. So in ECDIS, we have what we call an exchange set, that is the data sets structured in a specific format folder structure. And you has appended metadata and supporting information, pictures or additional files, additional binary data potentially. So you can ask how you want the information to be packaged through the Secom interface as well. And this is just the summary interface. So if you ask for a service, what can I get as an exchange set on S125 or S124, for instance, for that geometry? And the service will respond with whatever is available. You can see the outline of the data structure on the right-hand side of the presentation. But then the service will just respond with what's available. It will not just give you the data. So this is a good replacement of the S128, I think, catalog of naval publications, and can be used as such. But when you actually want to get the data, then you have a different interface, which is basically the get interface. This is very similar. It contains pretty much the same fields as the get summary, but it will return back the appropriate response of the data you have asked for. And that's why there's an additional field there, a data reference. So based on the dataset reference from the first interface, the get summary, you can actually query the specific dataset that you're interested in. So that's an additional option on the get interface. So all good and done. So you can see what data we have on a service, we can ask for it, and you can receive it. But this is not the only operation in which we can receive data through Secom, because we can also support subscriptions. And subscriptions are a bit of a more complicated operation here. So in subscriptions, a service will have to push information when it becomes available. But again, as Ramin mentioned yesterday, you don't always have a stable connection. So it's not like you can definitely use a WebSocket or so. So you need kind of like this closed loop operation and acknowledgement as well. So in Secom, you have three different interfaces effectively for the implementation of the subscription. Initially, you can request a subscription based on similar parameters as the get interface that we saw previously. But then you will also receive a notification, a confirmation that subscription was generated successfully. And then the service can now has the information that it needs and knows exactly the parameters of your query, and it will upload. This is the term used in Secom. It will upload the available data when it's available in your upload interface. That's a third interface. When the subscription is no longer needed, the client can remove the subscription, and then again, they will receive a notification that the subscription was successfully removed. So you have updates always on the subscription notification interface on what's the status of your subscription. And again, another very important interface in this operation is the upload interface, which can exist on its own, but it's also part of the subscription operation. So let's have a look at the upload interface and how does that look like. This interface allows actually anybody to push information to a consumer. It could potentially be used, for example, for notifications for important updates, potentially even without being subscribed to them. There is a potential for this. I'm not saying that Secom specifies that though. Now, the uploaded object, the uploaded data is actually encapsulated on what we call an envelope. That includes additional data, additional metadata, additional information about how the data looks like, how the data is packaged, because it's not, you haven't clearly necessarily specified, I want the data like this and you're going to receive it. Data will come through a subscription potentially in an unexpected way based on what the service can supply. So there's an envelope that can be signed independently on top of the signature on the data. So you're sure that the information you get is correct and that the metadata is also verified. You can see that on the right hand side, the outlook of the envelope upload object. You can see also that you can clearly define whether the upload is part of a subscription through the from subscription attribute. You can also have a transaction identifier, so you can identify which subscription the upload is part of. But there is a limit to what the upload interface can, there's a size limit to what the upload interface can accept. And that, I think, in Secom, correct me if I'm wrong, is specified to 350 kilobytes. It's relatively small. This is the base64 encoded data, not necessarily the binary data. Now, this is relatively small, but we have to keep in mind that this is a ship-to-shore or shore-to-ship communication, so we're not sure about the reliability of our communication channel. For potentially communication between authorities, as we would like to implement Secom in, I don't know if it would make sense to keep that limit. Potentially we wouldn't. But this is the actual limit specified in Secom. For larger data transfers, there's another similar interface that can be used. So we wouldn't necessarily upload through the subscription and the upload. We would use the upload or get by link. So again, it's a very similar interface, has similar structure. The data models defined for this, but effectively you would request someone to upload by link, and then the consumer would would have to make another step and get the data from the link that you provide. And that's why in the data model here, you have additional fields like size and time to live. So this is the size of the data I'm going to send. I cannot send it directly. You have that much time to get the data from my get by link interface through the transaction identifier that I provide. So it would work a bit like this. And then the consumer can actually use that interface again from the same service that they are in contact with. There's a few more interfaces that I would like to introduce. They're relatively simple. For example, there's a ping interface in Secom just to make sure that a service is up and running. That might be useful to give information to the user about the status of the service they're communicating with. This will respond simply with a timestamp on the last interaction. There's also a capability interface. That's a quite important interface. This allows and enhances the discoverability aspect of Secom. And that's because it allows services to query to consumers especially, or the producers as well, to query a service and find information about what's supported by the service. So the interface will respond with a list of the interfaces that are included in Secom and what they support. So it can say that I support a get by link, and a subscription. I don't support anything else, for example. So once you have the endpoint of the basic URL of a service, you can actually query it through Secom and find out which operations it supports. And then, for example, through Get Summary, you can find out what information the service has. So a consumer will have all the information they need without any manual intervention to know how to contact that service. And this is quite important in that standardization effort because it's supposed to automate these kind of operations. A clear difference between version 1 and version 2 of Secom, and again, I don't know if Ramin knows differently, but I'm aware, or as far as I'm aware, in Secom version 2, there is an intention to change the data product type from a single one, so a service can only support one product type, to multiple ones. So a service can respond with both, let's say, S124 and S125 if they are available. And that's a big advantage for the scalability of the system or the flexibility. Now, I won't go through other interfaces like the encryption or the access. You can find that in Secom itself. But because we don't have a lot of time, I want to go and look at the data structures that I mentioned previously. In Secom, many fields deal with date and time. In Secom version 1, I think that datetime fields were using the S100 format, and in a peculiar way because in S100, at least in version 5.2, the timestamp is using the ISO format if it's XML, but Secom version 1 was not using that. It was using the traditional S100 format. In Secom version 2, that discrepancy is rectified, so we're using also the ISO format for the dates. We've seen a bit the metadata in the data models of the interfaces, but I want to stay in that because it's a very important part of Secom. So the metadata objects or attributes that are included in the get summary, in the subscription, they include information about the data protection, whether the data is encrypted or not. They include information about the protection scheme, which algorithm we use to generate our signature, like elliptic curve or so, the digital signature itself, the public certificate that was used to generate that signature. And I think in Secom 2, it's the certificate chain as well. So there's an improvement. And also whether the data has been compressed or not. So there's a lot of very useful or necessary information to decrypt or handle the data, whether it's compressed, because it's base64 encoded usually in Secom. It's very important to know that. We also have the use of UUIDs in Secom. And this is something that some of us have struggled with to see how we're going to use them with other identifiers that we have potentially in S100 or with MRNs, maritime resource names that are proposed by IALA, which is a very nice identifier for anything maritime, really. So effectively, you can use an MRN to describe a data set or even entries in a data set. You can use it to describe a ship or equipment on a buoy as well. So it can be used for anything. And I think there's also an intention or a thought to use it as an interoperability identifier in S100. In Secom, however, we use UUIDs as data references for the transactions, data references for the data sets themselves. So the way the mapping works between the UUID and the identifiers in S100 or any other data you want to send through Secom, that is not clearly defined. It might be up to the technical service specification potentially. There was actually a very useful and very nice proposal by our colleagues in Finland to use UUIDs for every change on the dataset. So UUIDs could effectively be kind of like a hash key as we use in commits as the dataset progresses. I find that very nice idea, and it's again. Nice ideas are one of the reasons that we collaborate in the digital incubator and the MCP community. Other important data structures used in Secom is the geometry. We use the well-known type, which is basically a human-readable representation. It can support lines, polygons, etc., areas. It's not defining coordinate system. It's using by default the WGS 84. But I don't know if there would ever be a case for using GeoJSON. It might be nicer for web clients, but I don't really think there's a priority for that in Secom. I'm just covering that in case we have any questions. We already mentioned the UN law codes. These are mainly for, as I said, for ports or land-based locations. They're using 5 character combinations to describe, but not all locations have a geometry assigned to them. So you need to use them very carefully. And I don't know how much there is or you've taken so far, but Secom can look a bit complex, and we mentioned this yesterday because it's quite extensive and very thorough. But at the same time, we're using the same data structures, same configuration, same security operations, same interfaces, most importantly, and we reuse them over and over again. So it's ideal to develop a set of tools or standardized libraries that you can just put on your service and use Secom much more in a straightforward way. To that extent, in Grad, we've developed a Secom library based in Java, and it's available through GitHub. It provides you the Secom functionality right out of the box, and you can use it if you wish. It has direct integration with Spring Boot, but you can also use it in other REST easy frameworks such as Quarkus. We currently support both versions of 1 and a draft of 2, as long as it's not out, and you can actually use them both at the same time. And the functionality covers sections, not only the interface, but also security, the packaging, exception handling, logging operations. There's quite a lot of good functionality in there that would simplify your life. We have a Maven repository that you can download the compiled version from, but you can access the code, as I mentioned, on GitHub. I'm also showing a bit quickly the structure of the interface. So we have a JavaX and a Jakarta version of the core package, where we introduce the data structures and the interfaces through JAX-RS, and also the handlers for the security, exceptions, and packaging and stuff, and some utilities as well that you might find useful. And then we also have a specific second package for Spring Boot version 2 and version 3 integration. I think we're going to be moving to 4 soon, now that is out. And provides a configuration. It very nicely provides a Secom client based on the web client, HTTP web client of Spring Boot. Also allows for open API documentation and the REST easy servlet to connect it with Spring Boot. And you're more than welcome to use it through GitHub. Very quickly, I want to also cover the XML bindings repository that the community has been working on, because this is basically the data that are going to be transferring mostly. And we found it very useful to generate the data structures through parsers such as JAX-B. Usually in the hydrographic community, I know we're using feature catalogs to generate the data and the data sets. But in the software world, XSDs are the standard way of producing XML, and this is what the XML bindings repository tries to provide. Effectively, for every specification, we can have the specific verified XML binding, so that you're certain, or you're more sure that your data structure represents and can generate correctly the data product that you're interested in. All XSDs that are available through staging s100dev.net are being picked up automatically. But if there's a data product, for example, from Ayala, that's not available online, we can add it on a specific folder of the binding repo called specifications, and then there's a separate folder for the XML bindings. And we hopefully will have more than one programming languages supported in this XML repo. Again, this is available as an open repository through GitHub. It's actually under IHO, on the IHO account, and it's being administered by Nipwik. But feel free to make any pull requests and collaborate on this. So I'm afraid I took most of my time, but I might have time for a couple of questions. If yes, Thomas.
Yeah, I just want to draw the attention to the chat where there's some comments and questions.
Oh, yes. Thank you very much. So I can see that in Secom version 2, the data product type in capability is still 1 at the latest draft. Okay, maybe we can do it too. uh, and okay, yeah, that's in terms of the data product type. That Secom will be useful for S11RT data. I do not know. It's a good question, and maybe I'm not the most ideal person to respond to this. Whether Secom would be useful for S11RT data, which I'm not quite sure what it is. Anybody wants to help me? Oscar, yes?
Yeah, I'm not sure if you are the right person to ask since you did not mention any certificates. But yesterday it was mentioned that MTLS was dropped for Secom version 2. So I wonder if there are any documents somewhere that describe the specification of the header authentication in Secom 2.
I am not very involved in the discussions on Secom 2, so maybe someone else can respond. But as far as I understand, in Secom 2, there's still TLS security in place. I haven't got any information that this would change. It's a core part of the REST PKI security. I don't know if Ramin, yes?
Yeah, so MTLS is, MTLS wasn't required in CCOM 1, but it was de facto required by how things were written in it. But like I mentioned yesterday, the challenges in actually getting MTLS to work end to end, both in modern cloud environments and then when we start considering the challenges with implementing the last mile onboard vessels, it was deemed a bit easier to just change it so that the envelope, which was defined in some of the CCOM interfaces already for version 1, has now been included in all of the get. That used to be HTTP gets, but of course now have to be HTTP posts because we need to use the post body to post an envelope with a signature and certificate, etc., etc., etc. But those are all now being defined so that we can just make it a bit simpler to implement it in various environments. The Open API, the latest version of the Open API that Pat has created is, shared in the Digital Incubators Dropbox. So I think anyone who has access to that, you can contact, or I'm hoping that Thomas will, in addition to sharing the recordings, share our slides that we've published. So you can always contact me, for example, by email, and I can share the latest draft of the Open API.
Yeah, thank you. I will have a look there then.
All right. I'm afraid I've taken some of the time from the next presentation, so I will stop sharing and I will hand over to Oliver.
Yes. Thank you, Nikos. So just one moment here. There we go. You should hopefully see my screen, at least in a second. Yep, good. Thank you.
Great. Thank you.
Thank you. So yes, hello everybody. My name is Oliver Stensen Bæk. I'm a senior software engineer and a system architect at Digital Maritime Consultancy, and I will tell you a little bit about the Maritime Identity Registry, the MIR, and the Maritime Service Registry, the MSR, and also give you a few examples on actually how to use them. So to start with, what exactly is the MIR? So the MIR has been mentioned a few times, both today and yesterday, and the purpose of it is to be responsible for identity management and providing security functionality to entities of the MCP. So that's like authentication, authorization, and so on and so on. It is standardized in the IALA guideline 1183, and it also conforms to the PKI requirements that are described in Secom. The actual functionalities that it provides are identity management for maritime entities. So entities could be users, vessels, devices, services, and so on and so on. So any maritime entity. And then it also provides a public key infrastructure, so you're able to actually issue certificates that you can use for authentication for these entities. So so the identity management makes it basically possible to give any maritime entity a unique digital identity. And for any for every identity, we give them a unique identifier in the form of a maritime resource name, which has also been mentioned a few times. So it's a URN basically, but made specifically for the maritime domain. And then for specifically for vessels, we can also provide information to the identity in the form of the IMO number, MMSI, port of register, and so on and so on. Then we also have the PKI part of it. So the PKI makes it possible to assign a cryptographic identity to any entity that are registered in MIR in the form of a public-private key pair, where we use ECDSA, so elliptic curve DSA cryptography, and a digital certificate that you can then use to authenticate yourself toward anybody else to prove that you are who you claim to be. We follow common PKI standards. So we haven't reinvented what somebody else has actually already done. So we use RFC 5280 for X509 certificates and certificate verification lists. And we use RFC 6960 for the online certificate status protocol, which you can use for checking whether a certificate has been revoked or not. And then the actual certificate content and the cryptographic requirements that we have in the MIR follow this IALA guideline 1183. And then, of course, the certificates themselves can be used for especially machine-to-machine communication, where some kind of authentication and or authorization is needed. So for the actual certificates for the content of the certificates. We have this table here for the distinguished names field. So you can see we have the type. That's always an entity. That's something we have decided on, even though it's a user vessel, so on and so on. Then the entity has a common name. So for a user, that would be their actual full name. And for a vessel, it would be the name of the vessel, and devices, services. Service, we can have the domain name as the common name. And the same for ATONs and organizations and so on and so on. Then we have a reference to which organization the entity belongs to. And then for some entities like users and organization, we have we can assign an email address. Then of course the country where the entity and the organization of the entity belongs to. And then finally, as the UID, the unique identifier in the certificate, we have the MRN of the entity. Then we can also have some additional information in the certificate, which we put in the subject alternative name field. So here we can put like and these are especially useful for vessels. So we can put flag state, call sign, IMO number, MSI number, so on and so on. And also the MRN again, a permissions field, which can be used as a kind of a basis for authorization or access control. An alternative MRN, which could be useful for entities that are kind of belongs to different domains. So the entity could both have an identity in the MCP, but it could also have a kind of an IALA identity, like an ATON, for example. That would be something that would have multiple MRNs probably. Then we have a reference implementation of the MIR, which is licensed under the Apache 2 license. And that consists of 3 parts, basically. So we have a PKI library, which provides the kind of basic cryptographic functionality that we need to be able to actually create and pass MCP certificates. Then we have the actual MIR API, which is a REST API built on Java and Spring Boot, which we can actually use to manage maritime identities and create certificates and so on. And then as the third component, we have what we call the ID broker, which is actually Keycloak with some custom MIR specific extensions, which we use to provide token-based authentication based on OpenID Connect, which can then be used to authenticate to both the MIR and also the MSR APIs. And all the links to the implementation are here if you want to take a look at them. So as I said, the MIR API is a REST API for managing identities and certificates, and it requires authorization with either an OIDC token from a Keycloak, or you can also use a certificate that has already previously been issued by the MIR to authenticate. So here are the Open API definitions of these 2 versions of the API, if anybody wants to have a look at those. And then I've made a tiny little demo, and it's very basic here. So I have Postman here, where I have here, I want to see all the devices that are registered in my organization. So here you can see the URL contains a reference to an organization MRN, and here I have set that to my organization MRN, which is URN MRN MCP org MCC core. Then I can send that, and then as a result, you can see I get a very quite long list of all the devices that are registered in my organization. But let's say that I actually want to create a new device. So how do you do that? So there's also an endpoint for that, which again takes the MRN that of the organization that it should belong to, and then in the body, so it's a HTTP post, we put the MRN that the device should have, and then the name. And here I'm using the X519 specific API. So I can set that, and then you can see as a result, I get some information like the ID and the timestamp of when it was created, and so on and so on. But let's say now that I actually want to issue a certificate for this identity. So what I need to do to be able to do that is that I need to create a certificate signing request, which requires that we have a public-private key pair. So that's what I will create here. So I will create a elliptic curve private key with the P384 curve. So I'll do that. And then you can see if I try to write it out, I have a private key here. And now, just get my notes here so I do it correctly. Now I can actually create the signing request. So I'll also use OpenSSL to do that. And I'll use the private key that I just made, and I'll put it to a CSR file. And then, just to put something in the request, I put some information about the name and so on. But in the end, that will actually be replaced by information from the MIR database. So that looked to have worked. So I can then write that out, and you can see that I have a request now, which I will then copy to my clipboard here. Then we can, if we go back to the API, I can now, there's an endpoint for issuing a new certificate using a certificate signing request, which takes the organization MRN and the MRN of the device as input. And then in the body, it takes the actual, oops, I think I need to copy it again. There we go. So I can send that. Then you can see as the response, I get in the body a chain of 2 certificates. So the first certificate is actually the certificate for my entity, and then the second one is the certificate for the intermediate CA that has actually issued the certificate. So I can copy that, then just paste it into a file here. Oops. And then I can open it, and then you can see here that there is all the information for my device here. So that's the device that I just created, and then the intermediate CA certificate. Yep, so that was the MIR. So now we can go to the MSR. So yeah, the MSR is responsible for providing discoverability of digital services, such as navigation warnings, VTS, weather services, and so on and so on. It's standardized in the IALA guideline 1191 and also conforms to the service discoverability requirements of Secom. It uses the IALA guideline 1128 as the foundation for actually describing services, service instances. So that contains information about the actual endpoint, the geographical coverage of the service, service provider information, and so on. And yeah, it provides service registry. You can register your service in the service registry, and then consumers can then discover the services either by searching in a one single MSR, or actually by doing a global search, which propagates your search amongst like many MSRs. So yeah, so for global search, we have kind of two kinds of global search. Either you can just say, I want navigation warnings all over the world, or you can say, I want navigation warnings based on some specific geometry. So you can say, maybe you only want for the Baltic Sea, or you want navigation warnings along your route that you're sailing. And to be able to do that, we kind of need to somehow divide the world into areas. So for that, we have defined what we call search areas, which are basically based on the nav areas that many know, but expanded a bit to also cover inland waterways. So an example for searching in the service registry could be that you want to find navigation warning services along your route, and that route actually covers 3 of these search areas. So the service registry needs to propagate the search request to all the MSRs that have services in these 3 areas. So kind of how that looks like is kind of like this, where a consumer comes in and say that I want S124 services along my route, and it sends that to one specific MSR, and then that MSR will then figure out that okay, this route covers areas 1, 2, and 3, so it will send the search request out to all the other MSRs that have services that cover either area 1, 2, or 3. But it will not send the request to, for example, MSRs that only cover area 4. So for that, we of course also have an open source reference implementation, which is also licensed under the Apache 2 license. And you can find it here on this link if you want to have a look at it. And for the actual API definitions, we have kind of 2 different API definitions. So we have one for what we call the MCP public demonstrator, which is kind of currently the stable version of the MSR, and that has 2 different kind of APIs. So the first API is mostly for service registration, and then the other, where you can see there's Secom in the name, that's the actual Secom specific API. Then we have the other one where you can see it's for what we call the MCP test environment, and that's a version that's actually currently being developed. So it's I would say, kind of a beta version of a service registry that's compatible with this guideline 1191, where we have this global search functionality. And there's also the two different versions of the API. Yes, so now I will also give you a short demo on the MSR. So here, I've chosen to show you the web interface for the MSR because it's a bit easier to visualize than actual like command line functions. So I can I need to sign in here. Oop. There we go. So let's take service registration first. So you can see there's already 3 services registered here, one from DMA and 2 from Grab. But I also want to create a new one. And here you can either choose to just paste in a G1128 XML for describing your service, or you can say, no, I just want to type it in manually. So type in all the information. So on and so on. I don't want to bore you with that, but basically how it will end up looking like is that you have all the information about the service. Then for the actual service discoverability, as I said, we have 2 kind of searching. So we have the local search, which I can show you first. So let's say I want to search for navigation warnings, which is S124. I can search for that. And here I just get one result, which is a navigation warning service for Denmark. But let's say that instead I want to search for a global search, as we call it, and I want to search in a specific area. So what I can do is that, let's say that I want to search for this area here. So I can do the same search with the geometry and then say search. And then again, I get the same search back, result back. But then now you can see I also get one for Finland. And that result is actually, as you can see out here, is coming from another MSR. So that's proving that we can do the global search. Then maybe instead of searching on a geometry, I would just want to search all S124 services, so I can do the same again. And then now, we get even more services. So we also get for Canada, we get for Australia, Finland again, and Korea. I think that was in the end for me.
Thank you very much, Oliver.
Yep, thank you.
I will leave the questions for a bit later because we're a bit short of time, and we have a slot a bit later on. So I'll move directly to Jakob to continue this MCP exploration.
All right, can anybody hear me? Oliver, you have to give me a thumbs up in case you can hear me.
We hear you.
Right, so my name is Jakob Svenningsen. I'm a software engineer at DMC. And moving on into this MCP story, what I want to show you today is the portal really of the public demonstrator, the web interface that we will use when managing service instances within the MSR. So let me try to share my screen here. All right. You should be able to see my screen now.
Yes.
All right. So very conveniently, what Oliver just showed you before was a web demonstration of this global search. What I am showing you now is the general interface we have for managing services and finding services, and like the visual functionality that Oliver showed you just before is also something that I think we envision being available in here as well. But very conveniently, this is a joint management portal for operations within the identity registry and within the service registry. We're logging in using credentials, either username and passwords managed via Keycloak, or using a maritime identity, like using an MCP certificate, is one way of authenticating with this online portal. So this is the landing page, which just gives you some statistics, which I'm not going to spend time walking through. But the interesting thing happens in here in the service registry, where I can, first of all, in the services tab, look up services that we have in the MSR right now. And just if I didn't say it before, the instance that we are looking at here is our public demonstrator service registry instance. And there are a list of services here, which is very convenient. And if I wanted to add a new service, I would be able to do so here. When adding a service, we also have a specification that's interesting, in particular the IALA guideline G1128, which I have open hopefully in another tab here, which defines also how a service instance description should look like. And therefore, our service registry here also enables you to just pretty much copy the XML definition according to G1128. So it's easy to manage services and copy services in here if you need to. But this is pretty much just just a management interface where you specify the name, version, like what kind of service are we talking about. For instance, let's say we wanted to put in an S124 service, just like you saw before. We'd choose MSI and then the data product type to be S124. We'd fill out the status field and most importantly, the endpoint where you can reach the service. And then there are, of course, a couple of other things here. Yeah, and as we just saw in your demo before, it's also possible to, of course, define a geometry such that when you search for the service later, it will only show up if you select an area of interest in which the service is available. All right. Yeah, and let's just see as an example. I could look up, I know there is a service in here from AMSA. I can look it up. I can see the area which it is covering, and I can click on it and see the additional information. But again, this web interface here is just a what can we say, a convenient front end wrapper around the REST calls that we saw before. And again, those are also defined here in guideline G1191. As you showed, there are, of course, interfaces, or there are REST APIs for finding services, but there are also APIs for managing services, for updating services, and so forth. So yeah, this is the portal. This is the nice way of doing things. So I think, Nikos, I'll give the word back to you, and maybe you can also take questions, and we'll be happy to help answering them.
Thank you very much, Jakob. It looks really good, although I prefer the terminal from Oliver, personally.
Yes, I agree.
We are good in time. I think we have time for a couple of questions. Let's see. Do we have? I can't see any hands for some reason.
It has to mean that everything was perfectly clear then. So.
All right, perfect. Sounds good. So I guess then we can move on to Associate Professor Mikael Kirkidell Thompson. He's also known as the rock star of the MMS.
Well, thank you very much. I hope you see the right share.
I can see the MCP2 presentation.
Perfect. Yeah, so as Nico said, so now I have plenty of time to talk. That's always good. I will present the Maritime Messaging Service and what we're working on right now with the Maritime Trust System. As Nico said, I'm associate professor at the University of Copenhagen and Oslo, but more importantly here, I'm leading the working group on identities and security within the MCP or MCC consortium. So you have already, and I will not go in detail with this, but you have learned about the Maritime Identity Registry and Maritime Service Registry. And what you can do with that. But if we are sort of thinking about what it actually gives us in a wider aspect, it gives us the possibility to validate known identities to ensure that all identities are different in this context. And for those of you who know sort of about security, this is often the backbone of what we need with PKI and handling secure identities. So that's a very good start. But what it doesn't give us is the communication. So the standard CIA triad of confidentiality, integrity, availability. It also don't give us any way to do actually relationships between different identities in this context in any way. So the MRN has been seen to be used for that. That's not the intended of it. It is just sort of a token that should be used only as an identifier, and that is the way it's used in MIR. That should be no inherent semantical information in what you want with that. So now we have the trusted identities from the MIR and the MSR. So what can we use for that? Well, all the services and products that hopefully we are to see in the future can be based on that. So if you need identities, that is sort of where you should start, I think, because we have a common language, a harmonized interface for doing these things and where we can start from. It also can give us communication. We already saw the Secom, that is connection-based, secure, and authenticated communication. And I will talk about the Maritime Messaging Service that is in contrast to that message-based for secure and authenticated communication. And that also contains some subscription functionality in that build as well. So these two are sort of complementary communication protocols that can handle different kinds of communication. And I will also talk about what we're doing right now with the Maritime Trust System, that is to define decentralized and trusted relationships in sort of this world, building on what we have from these identities. This is ongoing work, so I will spend less time on that, but I'll come back to that a bit later. So as mentioned, the Maritime Messaging Services gives us a secure and reliable store and forward messaging format. It is based on distributed sort of known identities that we have from the MIR, the MCP certificates, and handles topic cast-based subscription. So if we look a bit more in the details, you can find a standard that is today available at RCTM 13900.0. yeah, that's the identifier for it. You can also go to the Maritime Connectivity platform website and find the documentation there. So if we are looking at a bit at the architecture from what is needed and what we have of the components of it, you can think of 3 layers that we're working at. The top layer is the local application interface or client, you can think of it, that is used by the services or applications that want to sort of do communication over the MMS. It is intended to be a easy way where you don't know of access to the functionality without needing to know all the details that are below. On the slightly inner layer, we have the MMS edge routers. These are the outer message passing interface that will handle sort of the outer transfer level. These are highly configurable in sort of the way they are designed, meaning that they can handle different kind of transport protocols. They can handle different applications or how communications are to be handled. So we can see that the edge router we probably would have on a ship might be quite different from what you would have on a service provider and in a harbor. And this is intended that there is a standard interface that they should have, but the functionality and how they handle the messages internally and forward that in their domain, that can be different. So that is highly configurable to the application that is needed. And then the inner layer would be the router network. I will not dwell much in that. It is sort of the handling of the message passing in the background. Most people will never be near to that, so it is just something that is set up to work to do the communication of the messages that are passed. So the whole system is defined over 3 protocols of different layers. At the top layer, we have what we call the Secure Maritime Message Protocol. This is a protocol that is intended to handle end-to-end security and guarantees. So the only way you really can get good and reliable guarantees on the internet or in any kind of connected system is end-to-end. So this is defined from that standard. So that can give you confidentiality, just encryption using the certificates that deliver guarantees, or at least trying to resend messages, and you can be notified if the messages don't go through. Non-repudiation, meaning you can get notification of messages arriving at the other side. It also supports message segmentation if you use larger messages in this context. Below that, there's the maritime message transfer protocol. So this is intended just to be the identifier, how the routing of the messages happens. This is based on mainly MRN level or the topics that is possible to subscribe to, and will handle sort of that inclusion of it. That layer also include message authentication, meaning that the messages are signed. So this is something that is not always included in the transfer level, but we think it's extremely important. And the only reason we want to do messaging in this domain, the maritime domain, is because we have authentication. We know where messages are coming from, and we have the identity registry to build this on, so we can do an integration with that. And in the lower level, we have all the transport protocols, and that can be as such any kind of protocol. So there are right now implemented support from both TCP/IP and for VDES services in this context. So yeah, if we're looking at a bit of the transport protocols, as mentioned, we can do it with standard TCP. So that means that on the individual connections between the components, there will be a TCP, and that could be with TLS connection based on the certificates of these components. But we can also extend it to any kind of non-IP or other kind of messaging protocol. Here's the example with VDES and terrestrial and SAT-based, where basically the edge router, because it is so flexible, can be extended with both handling VDES and IP depending on the context. So if you want to send some messages via VDES, it will be handled by the modem that then can transfer it to the LAN side and handle the message from there. So basically what it will do is bridging the gap you have where you before would have just a standard IP connection between the edge router and the router. Then you will bridge that to the other side. So actually the network will think that you just have an edge router standing locally, but the internal part will then bridge this connection that you otherwise would have. So if we are thinking a bit of how these components are integrated together, then the standard way of handling it would be that a service provider would have, for example, be registered with the MIR, handling the certificates, finding the services and look up. So these can be integrated directly in the communication because they are built on the same harmonized certificate in this context. Users can then either subscribe to some subjects that will then be forwarded to the messaging the services that will handle these kind of subscriptions. So you could do that internally, and the services that then sends messages with these topics would then be forwarded through the router network and reach the end user that subscribes to them. So this is to integrate all the components that we have in the system, both the service registry, the MIR, and the messaging service can actually work together in a more easy way and handle the messages in a nice way like this. There exists an open source implementation of the routers and edge routers if people want to set up and test the whole system themselves. So you can find it here on GitHub. It is with the Apache license as well. So that's the Aeronautics have made a web browser agent that you can also use to sort of interface with the MMS if you have some other network that is set up in this context. And as mentioned, there is the standards of the message service that is available at RTCM. We are now defining test standards that can then be used later for devices, and that sort of continuous work within RTCM if anyone are interested in joining that work as well. Then please contact me and I can put you in contact with the right persons. So if we're coming to the maritime trust system, as mentioned, this is sort of the other application we want to build on top of these identities that we have available. The whole idea is that we can use this to define more complex relationships between identities. So identities in itself is just knowing who someone are, but not knowing the relationship it has to some other identities in this context. And this you can do in this context. So that could be knowing an ATON certificate belongs to an authority. It could be knowing identity of a harbor, a person. Any device that you actually have would be that device. It can be defined as. It can also define other protocol data for ECDIS or similar. So the trust system will sort of, it's not in itself defining these relationship and how it should be. That could be done in the IALA guidelines, or could be other standards or that define actually what the relations are. So this again is a way to define, give the tool for everyone to define how relationship should be, and not for us to do it, because this can be applied in any kind of applications and can be quite useful in a wider sense. There should be or will always be some defined trust anchor, like you also know from the standard internet. We have a certificate authorities that are sort of the anchors behind everything. We cannot get around that. That's just a feature of the internet. We need to have some anchor knowledge of it. So this is designed, or the way we are designing it now, is to be sort of a decentralized handling of these delegations, that these relationships that are. So it can be used, as mentioned, to delegate trust. We can use it for authorizing. It is communication agnostic, just like the MMS is transport agnostic. So you can transfer it via Secom, MMS, any kind of protocol as such. Also, local networks would be fine, because it can also be used for offline communication and validations of it. So the trust delegations themselves will be built on cryptographic proof. So basically, signatures of the relationship. So this would be founded in the MCP certificates. It could also be other certificates. It's not that there anything special about these. It's X509 certificates. It's based on anyway, like Oliver talked about. So it could be anything as such, but by using the MCP certificates, again, we can get a harmonized system for handling this in an easy way, which is often the hard part in this context. Trust relations will be defined by a sort of restricted trust domain-specific language. This is to be defined in this guideline that's coming up. So I will not give too many details about it, but it should be sort of human readable in its context, and then the handling of it in the background can be a more machine applicable interface for it. So as mentioned, we are working right now on this trust system, so it is intended to be a first draft of a guideline that should be presented at the DTEC committee meeting at IALA here in the spring of 2026. If you want to join this work and you find it interesting in any way, then please contact me or Juho or Thomas or any other from NCP, and we can definitely include you in the work and being a member of the consortium, so you can get the influence that way, of course. Or of course, later at IALA, that will be, of course, go through the normal discussions and protocols for that. So I can see there are some things in the chat, but I don't know if that's questions.
I think it's mainly corrections towards me.
Yeah.
But we do have yes. I think Per mentioned that in Secom version 1 and 2, the response of the capability interface is an array, so you could actually fit multiple data product specifications in there. So that's actually it's a very useful feature, I think. At least for the future, we're going to have more complicated services. But in terms of questions, actually, we have a lot of time now until our scheduled next presentation, which is again me, to take any questions for the presentations previously. So anything on the MMS, on Jakob, on Oliver's piece. Don't see anything in the hands. But I do have a question, Michael. Can you confirm that the MMS, because there's always this kind of, I've encountered this discussion that the MMS is not IP based. Can we confirm that the MMS is actually an IP based operation, but it can also be extended to cover non-IP transport?
Yeah, so the MMS is transport agnostic as such. It is message passing, so you can do it over any kind of network. The protocol is defined in the first case as IP based, so that will be the backbone of any kind of communication, because that is the backbone of the internet communication we have. But they are then defined for VDES. There's a defined the extension for how to do that, and we can do that for any kind of communication protocol by bridging over that connection. But yes, you can say the backbone of it is IP-based because the router network is IP-based internet communication, and most of the communication that will happen from there will be IP-based.
Yeah, no, that's excellent. May I also say that I always find the trust system a bit, it's the black box that I can never grasp, but I think it's one of the most important bits of the MCP. And when it's finally realized and rolled out, it will be a game changer.
Yeah, we have written a white paper that can be clarified even more, and that's the process we're going through right now. So hopefully, for the guideline that with the draft we will have in spring, it would hopefully be more clear. But that is at least the feedback I would like to. So anyone that will be interested, any feedback that will be in this process would be nice.
I do have a hand up from Mike Davis, UKHO. Hello.
Hello, good morning, good afternoon. Can you hear me okay?
We can hear you. Great, yeah.
Thank you so much. Michael, yeah, this is a question for you. So my name is Mike Davis. I work as a geospatial developer with the UKHO, and as said, I think in yesterday's presentation, we've been doing some work with GRAD, a very simple R&D piece of work, just to explore Secom and the technologies and some of the basics at this point. We've not done a huge amount, certainly on the MCP, we've not done anything yet on the MCP side. Apologies, I can't turn my camera on. And what you're sharing, Michael, looks like fantastic detail for my colleagues which are more interested in the security side of things. So I'm going to share that with them. So thank you. It's very above my head though. And I'm just wondering, could you give, if I'm understanding this correctly, and my very basic still understanding of the Secom standard, is this in addition to the Secom standard, or is it in there and I've completely missed it because I've not got there yet, or is it in addition? And can you speak a bit into that?
Yeah, so personally, I would define it. I know Thomas also have it's been a longer discussion. I don't know if Thomas want to jump in before I say something that he don't agree with. Personally,
I will allow you to speak first.
Okay, so personally, I would define, yes, it is an addition. So these two standards are based on different principles of communication, where Secom is a connection base, so you make a connection from the source where you sent to the end. If you want to do so, we talked about subscription-based communication where we can do topic cast. That is significantly more difficult in that setting because everyone will still need to connect to the same server to do that. That's the whole idea of a more sort of decentral network where messages are passed around in that system and communicated. There has been talk about the MMS also being sort of the last mile, so from the shore to ships being able to communicate that. That would be possible to use it. I don't think it is necessary the application for it, because I think it is to think of these two as different applications. So I know in FinTraffic they are working on VDES terrestrial connection, and there I think it would be extremely useful because they would be able to use MMS to send messages of different topics that everyone then could ask to subscribe to, or they could receive it, and then internally on the ship, the equipment that need those kind of messages would be able to get it in this context.
Okay.
Thomas, you want to jump in?
Yeah. So we're coming with a lot of things here.
Yeah.
But the core thing is these technical services that we talked a lot about yesterday, and the technical services that are being specified now. And there was a list of several technical services yesterday. They all use on on the service design level, they are all using Secom. So if you want to make one of these technical services and implement them for delivering ATON information, navigational warnings, something, you need the Secom stuff, and you need the service registry and the identity registry from the MCP. That's it.
Yep.
So we include these components here because they are part of the MCP. So to sort of make the MCP story complete, we are adding these.
Okay.
I think in the future, the MMS may play a bigger role. We may see services that have an MMS-based service design, possibly. MMS may also be playing a role in the future for the last mile to Secom, possibly. I think in the longer run, when we have MCP everywhere and lots of technical services, I think the trust system will be crucial, but not right now. So I think we can better up the trust system right now, and in the future, it will be a need, and woof, we'll have it. So we're thinking a little bit ahead of time, because I think when we have a multiplicity of services, service providers, and different MCPs, we need the trust system to handle this complexity. But it's not crucial right now if you want to implement a specific service. That's my take on it. Thank you.
Okay, that makes a lot more sense now in my head. So I think the takeaway for me and us, I suppose, is to really watch this space. Is there a standard name, number, etc., that has been designated to this already that we should keep an eye on? Or I might have missed it in your slide.
You mean to the trust system?
Yeah, it's the MMS and the trust system.
Well, yeah, so the MMS, I know you had that several different EALA guidelines that are referred to there. Didn't have them in here, but that was mentioned, the provision of identities and the MSR guideline at EALA. And then there was the standard for MMS. We don't have any standards yet or number for the trust system. That is future work, as we haven't submitted anything yet, so we can.
Okay, very good, brilliant. Thank you all for your time. Really appreciate it.
Michael Bergman.
Yeah, I think the trust system is I think something of interest right now rather than in the future, as we may have service organizations, including us, which may be want to become an MCP service provider. If they're already MCP service provider, that only works if you have a trust system in place. So from that point of view, in order to move forward, we need to know how that trust system works, how we can access it, and that it's not something which will come in 2 or 3 or 4 years, but something which we can implement immediately as soon as we are saying, yes, we want to roll it out, and then we can also have a trust system between the current test systems, for example, or something like that. So it's nothing, so I bit disagree, Thomas, sorry for that, but it's nothing to say, okay, we don't need it, so when we get to it, then we will do it. If we want others to build MCPs, they need to have it available now to be able to implement it. Thank you.
Thomas?
You don't need the trust system to make your MCP implementation, and also your MCP implementation can contain whatever components of the MCP you want. So there's no hindrance in making an MCP instance by not having the trust system yet. Thank you.
So if I am to put my word on it, then the importance that this should be based on are the identities. So it's important we get that rolled out, and we can do a lot with that. I hope at least the plan should be that the future is 1 year from now. So perhaps the beginning of 2017, that will be something we can do. So if it goes through the guideline draft, then it might be adopted at EALA in the fall of 2026. And then after that, it's sort of just the usage. So the future is not far away. I hope not.
Thank you all. A really interesting discussion. But I mean, from my end, I think this is exactly where the advantages of standardization and international cooperation lie. We need to have these discussions. We don't need necessarily to agree, but as long as we standardize this kind of operations, then we can cooperate and collaborate. And I really appreciate Ayala, IMO, IHO that are working on this. Obviously, the digital incubator, which is a great initiative for us with limited resources working on these projects. And it has really helped us a lot to put forward proposals for our respective organizations. I don't see any more hands. I just want to point out something that popped in my mind based on yesterday's and today's discussions, which is the importance of the MRNs that's emerging. Because we've seen, we had previously potentially navigation warnings propagating through NAVTEX. Then we're talking about IP-based communications and how that works. The Secom is also a vessel for secure traffic and secure communication, but the MCP effectively transforms the communication from IP to MRN based. So effectively, and we're going to see it later on, you do not need the IP of a certain service or even the URL in the end to communicate with it. All you go with is effectively the MRNs. So you say, I want to talk to this MRN, whether it's through the MMS or Secom itself, through the service registries. You'll see how I'm going to demonstrate that in a bit, how it actually works. And it looks very complicated because it is. There's a lot of thoughts, there's a lot of use cases to be covered, and we've done it's decades worth of work being presented here. But in the end, it's pretty much like the internet. HTTP is not a simple protocol necessarily. You have all those headers, you have security considerations, you have certain limitations, but in the end, it works. You log onto a website, and the system is designed as such so that you don't have any barriers. And I think this is where the Secom and the MCP is moving forward. So it's MRN-based communication, and eventually it just works. You say, I want to talk to this MRN, I want to propagate these messages to these areas, and they will be delivered. Obviously, the communication cannot be a simple thing, and we're talking about very challenging conditions here. But eventually, the mariner should have a seamless experience. And not only the mariner, but any consumer of information. Because again, as my colleague Gareth mentioned yesterday, we're a lighthouse authority here in the GLA, and we want all interested parties to receive our aids navigation information, not only those covered by SOLAS necessarily. And that might be true for many organizations. Do we have any more comments or any more questions? I don't see any more hands. I can use this time to speed up the next presentation, which is going to be mine. So I will have a bit more time to go over some bits, unless anybody jumps in. Okay. So thank you very much, Mikael, Oliver, and Jakob. I will move on then, and I will share my screen again. The next presentation is a presentation of our own edge navigation service implementation over Secom, but I'm not going to focus much on that, and I will let you know why. So effectively, yes, we have a service. Yes, it's based on Secom. We actually use the library I presented previously with a certain number of interfaces. Like, again, as I mentioned in my previous presentation, we have the capability, we have acknowledgements, pings, and you can, let me make sure that I haven't logged out. So we can actually try the ping service, execute. There you go, and you get a response back. This is the Swagger interface, by the way, from the Open API. And I get the update in the version 1 Secom format. The service actually supports a version 2 interface. Again, the library makes it quite simple to implement. I can try again to ping the service, make sure it's up, and I get the new format in the response. What I want to show you though is how you interact with that service and how a software developer or a company that implements this communication will interact with the service as such. So let's say we have a service, it's somewhere on the web. In our case, it's on our radio navigation laboratory. It doesn't really matter. You might have a one-to-one connection and you might go directly to use that URL, but as we described previously, in Secom, you would usually do that through a service registry. Because you might want to talk to multiple services, or you might be moving from one location to another. So let's say we have a client, and in the GLA we've developed a test client that's also open source. It's on our GLA website, on account on GitHub. You can find us Aton service client, but I took the liberty to augment that a bit to include more navigation and more information like navigational warning. I would ask you actually to have a look at this under GitHub GLA-rad. And there is a branch there. It's called demo. And I can ask you also to have a play with this, maybe after today's discussion, because it's kind of like an exercise. If you're familiar with Java, or if you want to take up the challenge, there is, if you can download the software, and you can open it on an IDE, work on it with Java. Let me move. So I can open it with my IDE, for example, and I can look at my to-do list, and I've left a couple of areas there for whoever is interested to fill it in. So we have effectively a Secom service and a subscription service. These are internal components, actually. They're not technical services. They're internal components of the client that we aspire to connect to our Aton information service. So they're over here, the two services that need to be implemented. And here we have a section of controllers. So these are the interfaces that include the Secom interfaces. Now, if we go to the Secom service, we will see that we have two functions that we want to connect to our Aton service and get the datasets available and also the content for this. I've disabled, in this specific demo branch, I've disabled the security, so you can simply run it. And once it starts, we can actually have a look. Let me, sorry, it's actually building now. Actually, that's a good idea, because there's also a number of tests here that, because of the lack of the required software, will fail. So the task for after this discussion is basically, if any of you can fill in the required sections and get the tests to pass. This can also give you an idea of how to interact with the Secom service and how to interact with the Secom library. So we have a number of failures. So let's run the demo. This is a Spring Boot service, by the way. Gonna run, and it's running on port 8768. So we can go to my browser. Go, and I can use over here. That's our client. So you can see that the client already connects to a service registry, and I can actually view the services that are available, S124, S125. Currently, there's only one service, the service that we provide for Aton navigation information. That's around the UK and Ireland. And we have a certain set of data sets, but they're not visible here because the implementation is not there yet. So I would like to invite you to join me in implementing that and see how you can actually use the library, how you can actually use Secom as a developer. So looking at the get service data sets, that's the function that we're planning to implement. And we want to contact the Secom service and get the summary of the data sets. So let's do that. I have already implemented an initialization of my Secom clients. And you can actually see it over here on top. It might look complicated, but it really isn't. We effectively say we want an MRN to contact our client. This is what I was alluding to earlier. We're going to contact our discovery service, our service registry. We're going to ask for that specific MRN. We're going to get the results. And we're just going to choose the one with the latest version. Now, I'm aware that in the last upgrades of the MSR, the version of the MIR, the version is included now on the MRN. So this split is actually not required anymore. And then we just initialize the client based on the endpoint we received. So effectively, we have a layer of abstraction, and we say, I want a client with this MRN that's provided already by our service. So we get our client, and what do? I just want a summary. That's it. The Secom client is already there for us. I mentioned before that we could ask for the dataset as an S100 dataset or as an exchange set. In this case, we're going to choose a dataset, and I'm not going to provide any other arguments which are available in the function data product or product version. I hope you can see the screen is not very big, but I'm just going to basically leave everything else as now. Even pagination in this case. So this is effectively my query to the service based on the response of the service registry. And if something goes wrong, I'm just going to put an exception that's going to be handled by the library. And then I just want the summary object. There you go. And I'm going to stream the results, actually, and return it as a list. Let's see how that works. I try to update my code. There we go. So going back to my client, let me refresh the request. All right, now we have the list of datasets. You can see that we now have Trinity House, Irish Lights, Northern Lighthouse Board, and a test dataset. But there's nothing to get because I haven't implemented yet the getting function for this. Again, I'm going to implement this over here in the get service content. It doesn't have to be complicated again. We will once more call out clients, get client based on the MRN. I'm not looking for an IP. I'm not looking for an endpoint. It's there. And I can get now, based on the data reference, and I have a data reference selection here, data product, geometry. I can have different fields, which I can then provide programmatically onto my call. The data reference here comes as a string. So I want to use that as a UUID because that's the identifier used in Secom. So I'm going to use a data reference and map it as a UUID from string. Otherwise, if I haven't provided any, it's not enough. And then we have the data product type. There we go. Version, geometry. UN locode, as we mentioned in the previous presentation, valid from, valid to. We can add some pagination as well. It's that one. There's a question whether we have paged the request. If yes, if it's not unpaged, then we don't have to fill this in. If so, then we're just going to get the page number and the page size. That should be it. And if something goes wrong, we'll throw an exception. Now, this will return us a get response object. The library already has the, as I mentioned, the data structures defined. So I can just get the data, the list of data responses. In Java, I will just stream this, and I want to return a specific domain-specific object as a signed dataset content. This is what my service will read to represent to the user. So I'm going to get the standardized data response object. I'm going to map it to my own specific data structure, which is this. Okay. And I'm going to return this. And eventually I'm going to return this as a list. Now, there is a question here. Why is this complaining? I need one more argument. And again, my function will let me know what I've missed. I'm gonna go valid string time, valid from, valid to, change the number. Oh, I've missed the container type. All right, let's fill it in. Data set. Very good. So again, it makes it easy. The library guides you on what you need to fill in, what the service expects, because it's standardized. So let's make this as a mutable object. And let's just return the content, which is basically the content of my response. There you go. There's some more information included in a Secom response, as we mentioned before, which is in the metadata, is the security information. So my signed objects, my signed dataset content can also have information about who signed the object. Let's leave it as test for the time being, and who issued the object. Let's leave this value. Let's see if that's gonna work. Sometimes it asks for a restart. Let's restart the service. Take long. All right, there we go. Moving back, let's refresh this one. We have the service, we have the data sets. Now we can actually pick up the data. There you go. We have some information from the service. Not necessarily all of it is populated. And we can see that the dataset was signed by test and is issued by the trusted CA test. So the information that I provided by the service can now be directly displayed to the user. The library makes it easier for me. I don't need to implement the client. I don't need to implement the data structures, and I don't need to implement even the security of it because it's already handled by the service. I can also fill in the information from the metadata in the fields here. I actually have some utility functions that we can actually. Let me get first the certificate information from the response metadata. Here, I can get the signatures, and I can get the public certificate from that. And I can use my utility functions to extract the certificate from the PEM representation, which is available in there. And now, with the certificate in mind, I can use again my utilities to extract the UUID, so the UID from the certificate, and also extract X509 utils. I can also extract the issuer from my certificate. Let's run this. See how it looks. All right. Once more, let me get now the all data sets right now. And we'll load. Boom, there we go. Trinity House dataset, Irish Lights dataset, and LV dataset. And I can go and get my security information for every single entry, who issued it and who has signed it. And it's that simple, effectively, using a standardized protocol and a standardized library. Obviously, there's going to be mistakes and errors in the library, in software, but having it open, having it standardized means that we can actually have a look, we can check, we can scrutinize, and make it better. Even the way that we interpret the standards might be different, and that is okay as long as we know and can resolve this. Now, again, based on yesterday's question, maybe I don't want all the data. Maybe, as we've seen before, as a service now, as a client, I want the data from the service only for a specific location. We said that in Secom we're using WKT to get our information. So assume that I want to get information for a specific geometry. I'm just going to use a simple point here. And I'm just going to have in mind the coordinates from Harwich, where we are based. So does anybody know whether I should put the latitude or the longitude first, please? And not you, Ramin. Is there any hands whether I should put the latitude or the longitude first in my representation? Any hands? Anybody that can help me? Yes, Fredon?
I would say you use latitude first.
Latitude first. Is there any objections to that?
I think it's the opposite, but I might be wrong.
I will go with longitude first, and then latitude.
These discussions we're having at the IHO working group meetings for different S100 products, and it scares me.
Actually, the service does accept longitude first,
okay.
But every good developer will put a latitude first.
Thank you.
So this is where hydrography, I think, conflicts with standardized with development norms, let's say. And again, this is a great reason to have the standardization, because people will consider this differently. Actually, fun fact, all of the services that, most of them that you're also going to see here today, all of them apart from the Finnish one, we were putting the latitude first on the first iteration of our development. And then after we realized that we're actually conflicting, we had a chat and we basically switched to the Finnish model, which from the beginning they were complaining and they were saying we're the only ones that are right.
All the
yes,
Finnish
Ramin.
ATOMs were in the Gulf of Oman.
Yes. Yes, Ramin?
Yeah, just to make a note, EPSG 4326, which is basically WDGS 84, does specify in its standard that it is latitude, longitude. And since GML and S100 products default in most cases to EPSG 4326, that is the correct order in each and every case. So in a way, it is clear, but unfortunately, many of the standards do not state it clearly, so which has led to a lot of confusion.
But I think this is also the good reason for having the standards, that there is a solution to be found. If we were to develop services independently without Secom or without the standards or without the MCP in place that we can actually make them interoperable, then it would be much harder, and we would have to find these errors when we actually got the systems to work together. Yes, Oliver. Oliver, your hand is up. And you're not.
Sorry, I had to remember to actually take the microphone down. I think you're all right that it's almost always latitude, longitude, but WKT is a weird format in that way because that specifies, specifically longitude, latitude.
Yeah. So again, it's the collaboration. It's the simple things, the simple assumptions that we do, and we've made this mistake that basically helps us move forward. Simple things just like that. So in this case, we specified an area, a point, which is also only overlaps with one of our data sets, the one in Trinity House. And this is the one that the service returns, although I said, okay, give me everything you've got, but for this specific geometry. And again, this is how you would filter in your client. You could put a path, you could put a line or an area, and you would say, I just want the data sets that are applicable for the navigational warnings or the weather information that are applicable for that. There's also, the service also supports a subscription interface. I've left this for you to fill in. You can use the same method as we done with the client. You don't even have to connect to our service. You can just get the tests to pass. That would be an acceptable solution. Do contact me or Grad in general if you need assistance, if you're interested. We're more than happy to help and share. The service does receive, let me see, as arguments the I'll just open it in my properties here. Does it receive as arguments the key store and the trust store or the password? Yeah, feel free to play around. And that's it. Do you have any questions or any things you want to discuss? We have a few minutes. No? Everybody's happy?
Nikolaus, maybe I have a question.
Yes.
Yes. The purpose of these clients, for example, your Atom service client, is that to simulate a potential user, or it will be in the future the layer that the user system will use to communicate with the Secom service?
Well, basically, the clients we've designed, and most of this, we're mainly interested in the service provision rather than the clients as the Lighthouse Authority. So the client is effectively just a test or a demonstrator to identify issues with the service or to show the capabilities. Again, when we started with this, Secom was still being drafted, and we still have version 2 coming out. It's an emerging technology, so we need to test. And no, we're not planning to use the client in any way. We're planning to use the library, obviously, and the service part, but the client is just a tool towards that end. So we're not planning to use the client in a way. By the way, both the service and the client are open sourced, available on GitHub for you to play around and even break them if you can. And would be happy to receive any feedback.
Okay, thank you. It's very interesting. It's the first time I see it, so I was wondering if there was a purpose I didn't know about it. So thank you.
No problem. Let me actually. You can actually probably use it also for getting the navigation warning information. If I go, for example, for AMSA, if that's going to work. Well, I can get the navigation warnings from here, so I can get the list. Maybe not the navigation warnings though. Maybe not in the demo version at least. But yeah, feel free to play around and connect it to other services. That would be great. So on that note, thank you all for hanging in there with my presentation of the Aton service and the clients. And I think, Martin, you are the next person before the break as well, the last presentation, to take us over your implementation of the navigational warning service, S124.
Okay, sure. If you want, I can start right now, or is that correct?
Yes, please do.
Okay, good. I have prepared a PowerPoint presentation, and a part of it I'm going to make you a live demo instead of showing some slides. I think it will be more interesting. So give me 2 seconds. I'm going to share my screen. So let's see here. There, I think it will be correct. Okay, do you see my screen?
Yes, we can.
Yes, okay, good. So I'm going to start it. Okay, good. So my name is Martin Richard Cerda. I work in the Canadian Coast Guard. I'm working in the navigation team since 2018. And it's me who was in charge of implementing the S124 service. So yes, to start, this presentation to show the full. Yes.
Martin, you're showing your slide notes.
Oh, okay. No, that okay. Maybe. Thank
you, Evan.
So you cannot see the main.
We don't see the main presentation. You're sharing your wrong screen.
Okay. Okay. So I'm going to maybe try to share my screen again. Okay. I'm sorry for that. Maybe okay. Maybe this time. Okay. Can you see it now?
You see your slide deck, yeah.
Okay, and now if I'm in full, I don't know how to remove the side here.
You can just minimize the ribbon if you want, maybe from the chevron on the right-hand side.
Yeah, is there a full screen mode or something like that?
Not for us. We still see your slide deck.
Okay, yeah, that's not very.
I think if you press the screen next to the control at the bottom, there's a screen symbol.
Okay.
Right a bit.
Right.
A bit more. One more. That's it. No, one
okay,
more.
This one?
No, one more. Right, this one.
Oh, okay, this one. Okay, let's. Okay, yeah, but it shows like the next slide, but I don't want it to be displayed.
I think, Mate, I think you shared app, not screen, and it's not sharing the app that you want. But you can just use the slide deck as you have if you just hide the next slides on the side.
Maybe. Okay,
It's
yeah. So okay, good. Maybe like this, and maybe if I can zoom in a little bit.
The arrow up just be on the tab, the menu bar. There's a sort of, there's a hat symbol all the way to your right.
Okay.
Further to the right.
Further to the right.
Further to the right. Further to the right. Further to the right.
Okay.
Yeah.
Okay. Okay, thank you. So okay. So we'll go like that, like this, in that way. Okay. So I'm sorry for the interjection. So yeah, so here are the main points of the presentation. So the first thing I would like to show you is the overview of the architecture of our implementation. Then I'm going to show quickly the use of the Secom Java library developed by Nikolaus that he has talked in the previous presentation. Also a quick view of the Spring Boot framework, the GXB library, and then I'm going to show you with OpenAPI or Swagger how the service interacts. the interface of the requests, also the responses and the content of the request, and also the link to the MCP connectivity platform. How we have used it in our implementation. So okay, so the architecture. So we have here at the left our main system. We call it NIS. It's it's a variant, a different version of the NIOR system. We use it to publish and manage navwarms. So the navwarms created go to the database, and from there we have a exporter service that we use to publish some data in our portal. But also we have developed most recently the S124 web service that I'm going to show you here at the bottom. And how it works, it gets its navwarms from the NIST database and then converts it into the S124 format and give the response then to the user. Also, well, we have registered it in the MCP here in the bottom, so the service is discoverable in the MCP service registry. And we have also created an identity in the MCP. I'm going to talk about it later. And at the end, in the right, the user. So it can be ECDIS, ECS, or simply users. So that's the overview of the architecture. So as Nikolaus explained, they have developed a Secom Java library. We have used it to implement our service. Concretely, how it looks like, it's like most of the library are composed of interfaces that we need to implement in Java to create the service, and the interface forces us to give the same response. So it brings a standard way to return object that will look the same in every service that implements that interface of defined in the Secom Java library. And also the parameters, the interface defines the parameters, so we are forced to have the same parameters and the same signatures in the functions. So that's the purpose to help us standardize our parameters and responses. So yeah, and we have used the Spring Boot framework. Secom, the Secom Java library also used it, so it was a good thing to use it as well. So and in addition to the Secom library, we also have the GXB library that we use. That library, its purpose is to from Java objects transform them into XML formats. So we have some annotations like the one we see at the top of the class, and also attributes we see at the bottom here. It defines the structure of the XML content that will be generated. So basically, we have objects that contains other objects and each object has a conversion to a tag in the XML format. So the annotations help to structure that and have the final format with the right structure. So that's a very useful JXB library. I think also that Casper, one of our colleague and member of the digital incubator, has published some product definitions, like I think using the GXB library. So some of them can be reused to other to other people that would like to have the same format at the end in the response. So here is another example. So in that one, I use a function and I create the object that I just used in the previous slide. And from there, I set the values. And each values, as I said, because of the annotations from the JXP library, is associated with a specific tag in the final content that will be generated with the XML format. So that's for the GXP library. And now we have the interface of the request. So just like Nicolas, I've taken here 3 slides that describe the parameters, the different requests, but I think it would be more interesting to just show you the live results. So maybe if I move here the screen, can you see this new? Can you see here that I have a navigator here? Maybe I can just reshare the screen if you don't see it.
Yeah, we just see the presentation.
Okay, so maybe I'm just going to reshare it to make sure it's correctly. Just give me 2 seconds here. So there we go. Okay. So can you see it?
Yes.
Yes. Okay.
We can also see the Zoom window.
Oh, okay.
So we can see the whole.
Okay, thank you. I've removed it. Okay, thank you. Okay, so yes, here. So so just it's similar to the Atom service that Nicolas showed us. So maybe I can show you first the summary request here that we have implemented. So this helps for people that would like to communicate with our service. They can make tests here to see how it works. So here is a request and the different parameters that are optional. So you have the product version. So the latest implemented is version 2.0 of the S124's product. Also the geometry in this format, which is the WKT format with longitude first, as we don't like it, but it's defined like that. The dates are so if you would like to restrict the results in a time range, and also page. If the results is too big, you can reduce it in pages. So you have to choose a page and the size of the page also. So if we execute it without parameters, it will give you all the results. So here in Canada, we have a lot of navwarms. We have like, I think approximately 1,400. So that's a lot. So here is the response. So the list of each navwarm in the summary format. So as Nicolas explained just before, the summary format is like a summarized description of the navwarm. You have some basic information that usually will be used for the GET request if you want more information about specific navwarms. So here, for example, we have the data reference if you want to get that navwarm with the GET request to have more information. You have all the data product type, the series with the format we use here in Canada, the title of the navworm, its status, it's published, a description here in English. For this one, it's an aid. Its last modified date, the version. So the version we use by default is 2.0.0, but with the product version parameter, you can also get the 1.5.0 version and the version 1.0.0. And yeah, so it looks like this for the summary request. And I can show you the other one. So the get request here to have all the information of the navworm. So if, for example, we can execute it, it will take a little bit more time because it's each navworm has more information, and then we have 1,400, so it takes a couple of seconds. And for the get request also, the response is encoded in base 64, as I'm going to show you. So that means that we need to decode it, but I have a tool that I'm going to show you to decode it. So here, the first, so the response, maybe to show you quickly, you have the data, which is the content of the first here result. And also you have some metadata that is used for the signature, for example. So here we have the public certificate that has been created with the MCP identity registry. So the user can, for example, take that certificate and with the response here in the data field, validate if the integrity is correct. To do that, he has to make sure that the signature value here is the same than the one that he will generate with this algorithm. Yeah, so that's one of the example of the metadata available for each result. So if we want to decode it, since it's in base 64, we can just quickly decode it to show you how it looks like. Here, so if we decode it, here we have the result. So it's, as I told you, it's XML in the XML format. So we have here the identification of that navworm, the title, and other information like the category, the date. If we go there, we have also areas, the chart, the affected chart. Also, if we go here, you have also the position, maybe further, and yes, here. So for this one, it's a point. So other information like navworm type details also. For this one, we have 3. And the description, which is here, the text and the language English. So you have typically all the fields of the S124 format there. So if we go back here to the Open API interface, so yeah, and you can also use the parameters. So if you know the specific navworm with its ID given by the summary request, you can use it. The geometry also. So for example, maybe I can container type. So maybe just for the exemplar, for this example, I can maybe put a date here. So we can put October 1st. And until today, today we're 9. And so if you execute it, normally the result will be reduced because it's just 1 week approximately. So as you see, the result is smaller, and we can also have it in the if you put container type to 1, you can have the exchange sets format. It would be interesting to show you how it looks like. So there we go. Execute it, and now the response will be exchange set, which is encoded in base 64. So I just have to decode it quickly, show you. Just 2 seconds. There. Okay, there. So if I go, for example, to a file here, want to decode it, but into a file because it's a zip file. The exchange set, it's a zip file. I'll download it to you how it looks like. Oh, there is it is downloading. Yeah. To let it time to download, I can maybe go back to the presentation, and we'll see at the end when it will be ready. So yeah, so I just show you how you interact for the service. So for the moment, we have implemented these 2 requests: the object, the get request, and the summary request. So as I showed you, the response is encoded in base 64. The exchange set that I'm right now then leading looks like this. So at the end, I'm going to show you the zip file. When you put the container type parameter to 1. So in the exchange set, you also have the catalog XML file, which is compliant with the S100 exchange set. So it looks like this. And each individual GML file from the S100 exchange set looks like this. Gives you an idea of how it looks. And yes, maybe explain the link with the MCP. So we have created an identity in the MCP identity registry, and from there we have generated the private key and the public certificate that we add in our response. We use the private key to make the signature that we display in the response in our service. And with the public certificate, it's possible to validate the value of the signature. You decode it and see if you apply the hash algorithm, if it's the same value. So it allows users to validate the integrity of the data. So yeah, so it looks like that when you go to the MCP identity registry page and you set your identity. So in our case, it looks like that. And also we have registered our service in the MCP service registry. So here I've put a red rectangle to show our among the others. And yes, we have also had a basic square to our to the definition of our service S100 service to help users to find it if they they use coordinates to find which service is available there. And so yeah, and the endpoint URL here, you can see it. So that's the the URL you need to contact our S100 service. And that's it. So maybe I'm going to go back to see if the file is ready here to show you. Yes, it's ready. Okay. So here, the zip file, I've opened it. So the root folder, there, the root folder, and then you have the catalog XML file and the file that contains its signature if you want to validate its integrity. If we open it, okay, let's open it with Edge.
Martin, I'm a bit conscious of the time.
Oh, okay.
So
okay.
we can take a quick break for everybody. I know it's been quite a journey over these last few hours, but let's take a quick break and reconvene in like 10 minutes. And we can maybe take a couple of questions there or complete. And then,
Perfect.
And then move on to the next.
I will be available too if people have some questions. Thank you very much.
James Mann, a quick question now, maybe?
Yeah, it's a very quick question. Hopefully you can hear me.
Yes.
I noticed the file size there that came through was 335 kilobytes, and I'm just interested at looking the file sizes. I've seen some S124 files around the 1 to 2 kilobyte size, and I just wondered if Martin had an idea for the approximate average file size for the navigation warnings that are being produced in S124 XML format. Which I think is what we would actually look to distribute. I'm thinking from a VDES satellite perspective where size is critical. So the question is the size of the file that you're typically seeing for a navigation warning.
I will put a pause on that, and Martin will come back right after the break, if that's okay. All right.
Thank you.
So let's keep the
will give us
suspense.
time to respond. Good. Thank you.
Thank you.
Thank you, everybody. Let's reconvene in like 8 minutes and 10 seconds, that is, until the scheduled end of the break. So have a cup of coffee, everybody. Grab a quick bite, and we'll see you in a few minutes. Thank you. All right. Welcome back, everybody, or welcome back to those who had the time to come back. I know it's been a very short break, but again, we have a lot of things to cover. I think it would be a great idea to get some feedback after the workshop. See if if people find it useful. If people would like another type of an event like this, or maybe even an in-person event. There's always ideas there. And it also would be great for people who haven't already to join the digital incubator initiative. It's a collaborative group. I really appreciate it. And as an organization, we found it very useful for our development. So with that comments, I can start the second section of today's workshop with the presentations. The next presentation, hopefully people are or have come back from the break. The next presentation is given by Stelios Konstantaris from Hartis. Stelios, the floor is yours. I see some Steve, I think your mic is also on. Do you have a comment, or is it just a mistake?
Just a mistake. I'll turn it off.
All right. Thank you very much. Okay. Stelios, the floor is yours.
Thank you, Nikos. Let me share my screen, please. All right. You don't see the full screen, eh?
No, we do.
You do. Okay, thank you so much. Okay, good afternoon, good evening, good day, wherever you are in the universe. My name is Stelios Kontarinis. I'm from Hartis, and I will talk to you about how we implemented the Secom service to access and then to portray S122 marine protected area datasets. Just a few words about my company. We are based in Athens, Greece, since 2013. Our mission is to deliver cutting-edge geospatial solutions focusing on maritime safety and environmental sustainability. We specialized in hydrospatial technologies, emphasizing open science practices for hydrography and nautical cartography. And our expertise is to develop nautical charts, sailing guides, and environmental data products. The chart you see on the right, it's not where we are based, but it's the main MPA in Greece. It's the Park of Alonissos in the Sporades region, somewhere in the center of Greece. Let's move on. Okay, a few slides about the context of the marine protected areas. Most of you may know, but some may not know. These are designated areas by the member states that it's to protect the marine environment. There is an NGO in US, mainly based, called Protected Seas, that have compiled a very large database of official datasets. The database includes more than 24,000 MPAs. They have done that work over 9 years. They assume that they have worked for 46 person years. And the size of the database is more than 8,000 pages, and the area boundaries that have been digitized were more than 2,400. These MPAs, one information that they carry on is what the restriction there is there regarding to the shipping industry, to the maritime regulations. This can be restrictions regarding entry, discharge, speed, stopping, anchoring, landing, and the regulations are between either prohibited not to do that or restricted, there some allowance in the relevant regulation. Additionally, there are around 6,000 areas that are no take, no fishing, mining, or collecting, and 8,600 areas that have restricted take. If we see that the coverage of the MPAs, how we can map these MPAs, we can split them based on the ENC usage bands of the nautical charts. These are 6 levels displayed based on the area that they cover. We have 6 bands: the overview, the general, the coastal, the approach, the harbor, the berthing, which may cover a large area. Consider that the overview may cover the entire North Sea, and an example of MPH, the Great Barrier Reef in Australia. And at the last column, you may see how many MPAs could see at the approximate usage band. This will help us understand how we portray, how we show the maps, the MPAs on a map, how we select which MPAs to show. I will take you through our client. It's called Nav MPA. It's a smart S122 viewer. The URL is navmpa.hardis.org that you may use and look around. Utilizing the architecture that Ramin showed yesterday, we have a client called NavMPA, which it's where the vendor-specific implementations are on the left side, and we are consuming a service that Avin Navigation has developed for serving S122 datasets, and at the back it's the database of the protected seas that I was talking to you about. On the bottom, it's the Maritime Identity Service or the service registry of the MCP that we have used. If we zoom in a bit to our case, we have a client and a server. We have made a client on the left side, which includes a user interface, a proxy, and interaction layer. And then on the right side, we have the REST endpoints, a security and validation where all the security processes happen regarding certificates and integrity checks and the TLS. We have an MMPA data manager that manages the datasets and the payload processor that creates the multiple datasets upon request. The requests are actually the ones that our other colleagues have shown before, Martin and I think Nikos. It's one called summary request, where you get for, let's say, for a geometry, what datasets exist in that geometry, and then you can use the object request, where you can request the actual data of a specific object. Out of the information service that we received from Ivin, that is it has an API structure based on the Open API, we have used the points of capability of the object summary of the objects and the ping. And in order to set up the client authentication, we went to the management portal that you have seen before. And there we have created a certificate based on our MRN. It's harddisk.admin. These steps, you define the MRN, then you click add a certificate, you create a certificate, and you download the certificate. The certificates are of these types. You see also the MRN here, a certificate, a key store password, the private key, and the public key that we have used in our implementation. These are two examples that you have already seen. It's the object summary example with a geometry polygon and an object summary again with a geometry polygon. The first one retrieves a summary of the marine protected areas intersecting the specified polygon, and the second request retrieves the full S122 datasets. This is a simple proxy implementation where we can see how the certificates and the private key are being used, what is the endpoint that we are targeting to, the request of summary, and the request of the object. Okay, this is the first page that you will see when you visit the client. You have to register yourself, and then it will go you through the main page, which is like this. I will take you live in a few seconds. You will see first the viewer that gives an overview of how many marine protected areas exist in the world, and it starts getting data after you zoom after level 4, because if it starts working on level 3 or 2, the information will be huge. So as we'll zoom in, for example, here we are in Indonesia in the PAICC Aquatic Nature Sanctuary. We see on the left the MPAs that are shown on the map. There is shown there what is the area of each of the polygon that is shown. For example, the largest one is 445 square kilometers, and the rest you see the others. So that way we understand how big are the polygons that we are discussing and we are focusing upon. Also, there is a marking based on the main protected areas and zones within the protected areas. They have different marking. Okay, this is another slide showing the request sequence. So the user first navigates at the app. When the user stops panning, then a query starts and gets what are the MPAs for that specific bounding box. It returns the IDs and shows and gets also the data for the specific data sets in order to display the polygons. When users click on the polygon, it shows the details of the dataset for the specific MPA. I will show you that in a moment. Oh, here we have clicked on an MPA, and we see on the left that parsing of the S122 dataset. It shows what is the area, what is the jurisdiction, the status, the category, the restrictions, and what they allows us, and the regulations, and some other nautical information. This is an MPA restriction, but there are also zone restrictions within the MPA, so they are different, meaning that in the zones you may have maybe more restricted or different restrictions than the general MPA regulations. This is a slide just to show you if you have the S122 and show it in a QGIS, these are the raw information that you will see out of the polygons of that specific dataset. I will take you through the live demo. Okay, so we are on navmpa.hardis.org. We saw the first page. If we zoom in, we can see MPAs in the various places. Now we are on zoom 4. As we're starting zoom in, it will show here that fetching MPAs data through Secom. It fetched the MPAs. Green polygons have been shown. Let's click on the first one. And as we click on the first one, then the next call is happening. It gets the information for the specific dataset and shows the information about this marine protected area, the basic info, the restriction, regulation, and some nautical information, and the authorities that manage this specific area. So with this icon, we show that it's an MPA, and with this icon, we show that it's a zone within an MPA. So we went somewhere else, and we also see the information about the zoning here. Okay. there are some predefined. This is the one that I was talking to you on the slides. This is a PCCC. So it has zones within it that have different regulation. Let's say, okay. All right, and I will take you through the last point, which is that we are working on the portrayal of the regulations, meaning that we are trying to show easily to a nautical chart what are the regulations that exist for an area. This happens with a set of symbols, one symbol showing what is the marine species that are protected. Then the regulation is for what type of vessels and what restriction exists on the for that type of vessel. I can go back to the slides for that. Okay. So we see here clearly that there are different regulations for the whole MPA, but there are other regulations and other symbols for the zoning within the MPA, which are either allowance or restrictions, or prohibitions. Okay, we would be happy to get feedback. If you use it and you will go around, we will be happy to receive some feedback by using it. There is a feedback button on the top that pops up a form that you can complete and send us some feedback. Thank you so much. Happy to take any questions.
All right. Well, excellent presentation. Thank you very much. Did I pronounce your name? I am deeply ashamed of my Greek heritage now.
It's okay.
So
It's okay.
my apologies. Also, I think that Martin responded on the last question we got before the break. That's in the chat. Do we have any quick questions for Stelios? I did register on the app as you were demonstrating it. It's really nice. It's quite impressive. Thank you very much for sharing. I don't see any hands up. So we can have questions later on as well. But in the interest of time, I will move to the next presentation by, I hope I won't mispronounce that as well, Changwin Lee from Avinautics.
Yep. Can you hear me?
Yes, we can.
Okay. Can you see the screen as well?
Yes.
So, yeah. Hello, everyone. This is Changyun Lee, and I'm junior developer at Avinautics. And today I'm going to introduce you how I implemented the MPA provider service. I'll walk you through three main parts. How I designed a Secom compliant service, and how I used Secom library, and how I stored MPA in the database. So I think the MPA service is one of the simplest Secom services to implement because the main function is to deliver MPA data in a unidirectional manner. So no interaction is needed with the client. Because it works purely on request response basis, and get summary interfaces were the most natural starting point for this service. This is the initial schema I came up with. So the geometry field is used for spatial query, and the GML column is for the whole content of S122 file, and the rest is for the get summary metadata. So this is the sequence diagram for get interface. By using geometry attribute, it returns all MPAs whose geometries intersect with the requested area. And by using data reference, you have direct access to one specific MPA data. For the get summary interface, it works similar to the get interface because it uses the geometry field. For those who may not know, the filter object in the Secom standard is a list of attributes that can be included in the request of the consumer. So the data reference is used for single fetch, and the container type is this service only provides the data set, so data set is supported, and for the data product type, S122 is supported, and the rest version and UN locode valid from and to is not in use right now. And the pagination is mandatory because it's the request for the list. So I set the default page and page size, and in my case, I set the maximum page size to 50 for the get interface. And as you may know, the geometry field is should only be in the well-known text type, well-known text. Yeah, so the get summary filter object is almost the same as the get filter object, but it doesn't have the data reference. And I set the page size, default page size, a bit bigger because it's the metadata. I used the Secom library from the GLA GitHub. And as you all may know, Secom library is a library that automatically handles data signing and encoding, signature verification, etc. that is required for Secom communications. So all you need to do is just implement the provider interfaces that are in this library. For those who are using Gradle, you have to add a custom Maven repository like this. And there are 5 providers that in the Secom library, but I didn't use the data encryption and compression, so I just implemented 3 providers. So this signature provider is for generating and validating the digital signatures, and certificate provider is for supplying the certificate chain and public key for signing operations, and the trust store provider is for getting the trust store from the application. First, you have to register your service entity to the MIR. and issue a certificate. And when you download it, you get your certificate and the private key that can be used to generate your key store and trust store. For example, in this comment, you can use OpenSSL and key tool for generating key store and trust store. Yeah, so in Secom library, there is a class that's named Secom config properties that automatically scans your application.yml to get the key store and the password and trust store as well. So when you are implementing the provider class, you can simply use this config properties. For example, in in this code, I used key store utils dot get key store, and all the parameters needed in this method came from the config properties. You have to override those methods so that the Secom library automatically sign and do all the stuff needed to use this Secom. For the Secom communication channel security, the mutual TLS is needed, I think. And there are many ways to do that, but I used this application level setup in this configuration file. You have to set your client auth to need. And for the OCSP validation is also recommended. So I try to use this JSSE check, but since it runs synchronously inside the JVM, it takes a little time for per request. So, but it's the standard approach that, yeah, because OCSP validation is meant to do during the TLS handshake. I'm not sure there's the best practice for OCSP validation, but I can think that OCSP stapling supported by Nginx is also a good way, and either you can generate your own OCSP client that works after the handshake. So this Spring Boot project has a 3-layer architecture. So the controller implements the Secom interfaces. In the service layer, it generates the response objects. In the repository layer, it executes spatial queries based on the filter object. As Telio said, I implemented 4 interfaces, and this ping is the simplest interface to implement. I just used this servlet request listener and overrided request destroyed method. For capability, you can either set the available interfaces manually, but in my case, I I made this Spring Boot to inspect the current application context and check which Secom interfaces are implemented as Spring Beans like this. It's get interface, and the the data response object includes data, which is the entire S122 GML base encoded in base 64. And for the summary object, I used data reference and the info identifier, and I calculated the size of the GML file in kilobyte. So this is what the JSON response looks like. And now I'm going to talk a little bit about how I stored MPA. I used Spring Batch to read the GML files from the protected Cs, which is in all in the zip file. And I used JAXB to parse the XML and made it into a Java object like this. So the objects are converted to DTO, and it builds well-known text polygon geometry from the polygon attribute from the XML. And it uses this field to batch insert all MPAs in the database. For now, it takes 2 minutes to store 50,000 files. And in the future, I hope I'm planning to make a monthly update pipeline using this same configuration and automatically loading the latest data set from the protected Cs. This is an example of how I generated a spatial query using JOOQ. And this is how it looks like. It basically converts your input well-known text to the geometry type and uses this parameter to calculate the intersecting geometry and the pagination. And I also created a index generalized search tree on the geometry field, and it's working well, quite fast, as you can see. And before the nav MPA was there, I tried to test like this. And also, it's registered in the MSR. I tried to make this service to cover the entire world, but it looks quite weird. So the endpoint URI is right here. Thank you. Thank you for listening.
Thank you very much. Great presentation. I really love the capability implementation. Actually, I think that could be a default implementation. We wouldn't have to touch it ever again. So that was really, really great. I'm quite cautious of the time, so we'll take all the questions in the end, but feel free to comment in the chat. But I will move straight away to the next and final presentation from my good friend Ramin.
Hello again. Let's get things set up. So we've previously today been covering a lot of deeply technical topics and gone down to the level of code and shells and all of that fun stuff that the developer in me likes. But I'll take us back a bit, take us a bit further into the abstract or above a bit and look at G1128, which many of us have referred to, about what does that actually say, what are the contents there, and then I'll give a brief description of a service we've developed in Finland and a service that we're going to start developing in Finland, and then go over some lessons learned as well. So G1128, I referred to this yesterday. Several others here have also referred to service specifications, service designs, etc. And G1128 is the IALA guideline on how to specify technical services for the maritime domain. And it describes 3 layers. The first layer is the service specification, which basically describes the data model of the service, the business processes, and specifically, this is technology agnostic. So we could have a service specification and under that, several different service designs using different technologies, but still conforming to the same business processes, using the same data model, etc. And like I mentioned, the next level is the service design, which is then technology specific, for example, using Secom, which then is based on the specification. It goes into more technical detail of how is this specification actually realized as a service and a consumer of the service. So that's the basis of the actual implementation. And then, of course, we would have the third level, which is the actual service implementation, which is a service that implements a design, or in fact, it could implement multiple designs. It could implement multiple different versions of a design, or then it could be a service that supports several different designs. So we could have a single service that supports both marine protected areas and navigational warnings and aids to navigation, for example. But that's the basic idea of what G1128 describes. It also comes with templates for all of these documents, including a template for designs tailored for Secom. So we've done the heavy lifting of filling the template, the basic or technology agnostic template for a design, filled it up with Secom related matters. So if you start working on a design that is based on that will, use Secom, then you have a lot of the things ready there. And then another major thing that also applies to the S100 products as well. So it's also IHO uses the same versioning scheme for their product specifications. We're using the same versioning scheme for these technical specifications, which means that if the major version is odd numbered, that's for testing or development, but it's basically we're still testing that specification or design. And then when we get to an even numbered major version, that's for production use. I'm not certain, do we have any service specifications or service designs at the moment nearing the level of being at 2.0? at the moment. So all of the ones we currently have are either under development or are at version 1 point something, which indicates that they're there for testing. What is missing in G1128 is this big bad word called testing. We opened a discussion just last week in DTech 5 around this, and we're hoping to have a bit more discussion specifically in the Open Digital Incubator sessions around how we could incorporate guidelines around testing into G1128. But the main goal would be that in the next DTech session, which is in March 2026, we would have something that we could write into the next version of G1128. And at least from my point of view, the idea should be that when we get to an even numbered version of the specification or the design of a service, then those would have instructions on how to test how to test the implementations built around that specification and the design. This is very paramount if we want to ensure interoperability, and I will get back to this point later on in this presentation. But the challenge, of course, is that we have services and consumers that both of them have HTTP clients and servers, in many cases at least. They are developed by multiple parties, and they're developed in different languages and frameworks. So we've seen earlier that a lot of parties now are using the Java Secom libraries that GLA has gracefully provided us. But here in Finland, we've been developing all of our applications or all of our services using Node.js and Go partially. Partially from the perspective of our developers, because they come from a background of modern web development and are thus more familiar these days with node development, etc. But that just highlights the fact that the services themselves may be developed in multiple different languages and frameworks, but then also we'll have consumers that are developed using multiple languages and frameworks. If we're talking about shipboard devices and specifically ECDIS, in those cases, we're most likely talking about, at least based on what I've been looking at, C, C++, C#, these kinds of environments. But on the other hand, when we have web clients utilizing these services, or we have other ship systems that would be the clients or the consumers of these services, we can't be so certain of what the development language or framework is that is used. But like we've seen with NavUI, which is able to show the information from multiple different navigational warning services, it is possible to make these services interoperable. And then, just as a source of additional information, there's this IALA site which describes IALA technical services, which then has links to G1128. It has links to G1183, which was the Maritime Identity Register specification, G1191, which is the specification for the service registries. And then it also has links to all of the technical service specifications and designs that IALA has published. I highlight Root Exchange here, but also there's others that are published there. Then, of course, if you want to access some test data that is provided for Secom by IEC, you can get them from CIRM. And also there's test data for root exchange or root files specifically available there. Although currently these are only for version 1. And like I mentioned, Secom version 2 is under development, and root for S421 version 2 is also under development at the moment. But now we'll go and look at traffic clearance service, which is the first technical service specification that we defined in IALA. Traffic clearance is one of the main tasks for VTS, so of course it fit the VTS committee of IALA pretty well to take traffic clearance as one of the first services to define. But it was also selected because it is a good case study to explore the process of defining a maritime technical service, specifically a service that requires bidirectional communication between both parties. It was very much a learning situation for both the technical and operational stakeholders. For most of us coming from a more technical background, being dropped into the maritime world with much slower processes than at least someone who has a strong web development background like me is used to was very much a learning curve. But then it was also a learning curve for the operational stakeholders to start thinking about their business processes in a way that can be described as actual use cases that can then be used to derive the requirements for the services and then drive the actual implementation of the service. So it was a very beneficial way of starting, and it really highlighted the importance of defining the use cases in collaboration with all of the necessary stakeholders. And the problem, of course, is that in IALA, we are just thinking about or discussing things from a shore-based perspective. That is not a place where, even though there are many people there with a mariner background, we would actually have the end users or the other side of the process also present and parties of the discussion. But still, we got enough perspective, at least from a technical standpoint, for how these services could possibly be used. So what traffic clearance actually is, it's bidirectional communication between the VTS and the ship. It is always initiated by the ship. So the ship is requesting clearance from VTS to do something. It may be clearance to enter a VTS area, enter an anchorage area, start anchoring, enter a harbor, enter a strait, depart a berth, or whatever. But it's basically, it always starts from the ship, and the VTS might have some change requests that they come up with. So there's bidirectional communication going from between the VTS and the ship, at least for a few rounds. So the service design then, of course, is done using Secom. And then the data or the payload is very simple structured messages based on S212, or it's a subset of S212. And S212 is the data product specification related for the VTS information. And currently, the data required by traffic clearance service is the only set of data in S212, but it will be expanded in the future. I know of two implementations for traffic clearance service. So we developed the service in Finland, and I know that Korea has also developed a traffic clearance service. They also have a client for it, and we've also developed a test client, or in Finland, there was a test client developed on top of an ECDIS kernel by Novia as a part of the MEDAM project, which was referred to several times yesterday. And the fact that we were simultaneously developing the services and test and clients for this in two different countries highlighted a lot of issues, but it was also extremely beneficial. it really highlighted the challenge of creating interoperable bidirectional services in this world. But briefly, and to highlight the simplicity in a way of traffic clearance service, at least from a technical perspective and from an interface perspective, was that it only uses the upload interface, the acknowledgement interface, and then on the service side, there's a subscription and remove subscription interfaces that are supported. That's all that's required for it. And in fact, I have to remember and mention at this point of time, of course, both the consumer and the service have implemented the ping and capability interfaces because they are always required by Secom to be implemented. Then, of course, we have the route exchange service for which the specification and design were both published this year in March or in June after the Ayala Council meeting, but they were approved by the VTS committee in March this year already. And route exchange service is specified because support for bidirectional route exchange using Secom and S421 is required by IMO in the next generation of ECDIS devices. And the problem is that there's no service specifications around this. The IEC, the versions 1 of the Secom standard and S421 standard from IEC define some use cases around these, but those use cases aren't described at a level that you could create services and consumers that are actually interoperable. So in Ayala, we started the process of creating a service specification and a service design for route exchange using Secom and S421. It's done again under the VTS committee there because VTS is again one of the main stakeholders on the shore side for route exchange, especially in the context that it was mandated by IMO. And then currently now then the IEC standards 63173-1 and -2, which are the S421 and Secom standards, are being updated based on the specification and design, specifically in the annexes and use cases related to route exchange, from this perspective at least. Here's the business process. I don't expect you to be able to read it or look at it. This is in the service specification for route exchange, but it is not exactly a simple business process. And I would like to highlight something I mentioned yesterday in the architecture part. There are lots of these little timer icons in the business process, which means that one side of the communication is waiting asynchronously for a response from the other side. So this is very much an asynchronous process and thus is quite a bit more complex than the previously described marine protected areas or navigational warning services where we're mostly just getting information asynchronously from the service to the consumer. So the use of the route exchange service from a VTS perspective specifically is that they use the received route to check the route. They use it also for monitoring to ensure that the vessels stay along the route that they had planned. But also from then a ship perspective, they allow the use of route reference libraries. So you can search for route references and get example routes through an area. So you get a route with waypoints, etc., that you can then use in your own route planning. S421 version 2, like I mentioned, is under development by IEC, and it should be released in line with the next Secom version at the end of next year or beginning of 27. Again, we're using Secom for this, and we already know that the root exchange service will be utilized by multiple future services. For example, underkeel clearance service, for which the specification work has started in IAL now, will also be utilizing the root exchange service as a part of its functions. And in addition to Finland, I do know that multiple other organizations are starting their work on implementing their root exchange services as well. But when we look at it at the specification or the design level already, we can see that we're using a lot more of the Secom interfaces now. Upload link, acknowledgements, of course, get summary, which is the get summary is only supported by the service because that's more in use for the root reference libraries. There's the get by link, which is basically you needed for upload link to function. Then there's access and access notification, which is optional for the consumer in the latest version of the service design. Then we have subscriptions on both sides, and then we have encryption or support for encryption, which is optional for the consumer as well. I won't go into the nitty-gritty of how all of this works, etc. The specification and the design are fairly long. But then for the challenges and lessons learned that we've gotten during the process of defining these two services and designs and actually then implementing the traffic clearance service so far and having the implementation being done in two locations at the same time, we noticed that ensuring interoperability between services and consumers is difficult. Even though as architects, the idea is, and you imagine that when you're writing a specification and a design, it is clear and understandable for everyone. We noticed that developers did not always understand it in the same way, and specifically developers in another country and another culture did not understand them exactly in the same way. So, like I said, with the traffic clearance service, we really benefited from the fact that it was being implemented both the service side and the consumer side by multiple organizations at the same time. And a lot of these misunderstandings could be clarified very quickly, and we could also then push them into the next version of the specification and design. So we could clarify these very dynamically. It also showed that there is a really strong need for this phase 1.0 for the specifications and designs, with the fact that we need this testing phase before we can get to a production phase of the specifications and designs. But what it also, in a way, highlighted is, and again, this is something I mentioned earlier, that we're not defining these business processes around the maritime technical services end to end, because there is no forum currently where we can have all of the stakeholders discussing. The services are being defined and developed very much from a shore-based perspective without having representatives of the consumer implementers or the actual consumer users really present in these discussions. And anyone who's worked in IT for a longer time knows that this kind of single point of view is not always the best solution for developing these applications. So this is something I would like to invite everyone, especially if we have the consumer or shipboard device manufacturers present here, I would like to invite you to participate in the digital incubator at least, so that we would have one forum more where we can discuss from the multiple viewpoints on how to implement these services and consumers. And then another thing I would like to highlight is that it is something that we are still very far from tackling. We briefly mentioned this yesterday also, and it's the complexity of the human factors around all of this. So we are adding new complexities to both VTS systems, ship systems. They will hopefully help end users in the end, but as we always know, adding new services, new functionalities to computer systems has a learning curve. And this is something we are still not really discussing or tackling. We're very much at the level of technical interfaces, getting data moving from one point to another, but not actually solving the human factor issues that are also related to all of this. But that's something for us to work on in the future. But to highlight the lessons learned that I've covered briefly at least, we need to have testing information in the specifications and designs to ensure the interoperability. Because that will, in a way, when you have the information against which you need to test, hopefully also including machine readable or runnable tests, that will ensure interoperability. And specifically with root exchange, that is of paramount importance that we can ensure that the consumers and services are interoperable. We also need more and more example data to support development and testing, and we would need that data to be realistic. I'm really happy that for the navigational warnings and the marine protected areas, we actually have real data that we can use in testing. That has been very much was a problem in the early development of traffic clearance service. It's also very much an issue, or has been an issue, with route exchange service, that we don't really have good example routes to test against. We are now slowly getting them, which helps a lot. And then again, the cooperation between stakeholders during development is extremely helpful and beneficial for all parties. Thank you. I think I managed to stay in my time slot.
You were perfect.
Yeah. So thank you. And I hope now is the time for questions then.
Yes, we already have some questions. Thank you for your presentation. Thank you, Ramin. And we already have a question in the channel regarding the aspects of type approval and carriage requirements. Have they been addressed? And as we're talking of bringing new software on board of ships or interfacing, for example, with ECDIS, this needs to be clarified early for all parties involved. So is there any input on that? I know we've been discussing these points quite thoroughly over the past couple of years at least. Is there anybody who wants to take the lead on that answer? Shall I? I don't see any hands. So I know we covered yesterday the inclusion of route plan exchange on S98. Oh, we have Ramin. Yes, Ramin?
Yeah, well, I can't answer about S98 as such. That's something I'm not that familiar with. But of course, with the route plan, I do know, and I recognize that there's lots of names here also who know this discussion, that then in the IEC TC80, both the working group 17 and the maintenance team 7, which is then working on the next ECDIS testing standards, of course, for what exactly the route exchange or bidirectional route exchange and the support for that, what does it mean for the ECDIS and its testing, that is specifically being discussed there and should be covered in the next version of, I think it was 61174, which was the ECDIS testing standard.
Thank you for that. We also addressed yesterday the point where the actual Secom interface doesn't have to be placed on board the ship itself. We have this thing called the last mile, which can and most likely will finish at the shore side, and then it's the ECDIS manufacturer to devise the mechanism under which you can transfer the information over that last mile. That being said, maybe some manufacturers will decide to put the last mile communication on the ship itself. So the ECDIS consumer and ECDIS interface will be on board. That's not for us to define, and this is kind of this ambiguity is more of a feature rather than an issue. It was designed to allow the manufacturers to make that decision where and how they're going to decide, because also at the time of the specification, it wasn't clear. And there's a lot of the discussion now in the IMO, in NCSR, on how to devise the whole IP communication between ship and shore, and whether Secom and the MCP can be a part of it or should be a part of it. I think the discussion goes that they're primary examples, but we'll see where that will lead. So there is a great discussion of type approval and how the implementation of Secom services will affect that. I don't know if as Ramin said, I don't know if we have final answers to this, but there's definitely a lot of work on this item. Any more input on that answer? I don't see any more hands. Kirsten, are you happy with that?
Yes, it's me, Kirsten Giepers. Thanks for the extension on that topic. It's for myself or for the environment I'm working in. It's very interesting and important. I'm involved in the shipping business and in the manufacture and in the development of infrastructure and setup. And I was involved in the ECDIS development from the very early stage. I know that this becomes a very heavy burden after having survived the challenges of the development itself, to bring it on board and to make it operational. That's a huge further step. We have to include also the training aspect for the people on board. With this becomes some topic also for the whole training and expertise discussion. So we don't have anyone on board who is dedicated to the whole IT administration, and this falls definitely into this field. So we have certain shallow areas that we have to bypass to make it some day-by-day business and some day-by-day used product. Very much looking forward to participate.
Thank you for that. That point has also been raised multiple times, not just for Secom, but for the whole IT equipment on board ships. There was actually an input paper discussing that specific aspects in NCSR 12 regarding training and certification and how IT systems can be and should be updated, operated, included training for the board members. So yes, you are absolutely right, and thank you for your input.
Thank you.
Any more comments or questions regarding all the presentations we had today? I do have a comment on the last presentation of Ramin, where basically it's my common proposal. I've voiced it in the past to use techniques like pacts and consumer-driven contracts to test web services. That's ideally for most likely just for web services themselves and REST requests, but it's a quite powerful tool to introduce in order to make sure interoperability and conformance to the consumer followed standards. So consumer-driven contracts is a proposal that we're looking into in Grad. So I will offer the floor to Thomas now to close the session, and we can also receive any last-minute questions if there is available. So Thomas, the floor is yours.
Thank you very much. So I think we have finished the Q&A part. So I'll be just rounding up this seminar and do a little promotion. So yeah, this seminar was brought to you by the Open Digital Incubator. We hope you enjoyed it and found it useful. We've been recording this, of course, as you know, and soon these recordings will be made available on the website of the Digital Incubator. I will try, now it's been mentioned a few times that people would also like to see the presentations. So all the presentations I will also those I receive, I'll make available on the website. The website, of course, is the digitalincubator.maritimeconnectivity.net. You know that, otherwise you probably haven't found this Zoom link that we're using. If anybody have any thoughts about the seminar itself, any positive, negative, any constructive feedback, any ideas on how to improve it, we are very open to hear that. You can say something now or just send me an email. If you have any devastating criticism, just send an email. We will probably do this again. I think from my personal perspective, this has been a great success, and I really enjoyed that it was more interactive here on day 2, where it was more on the practical level, and there was more discussions and questions. So, and we had a good attendance. So I think from my perspective, this has been quite good. Michael.
Yes, I just want to more or less echo what you were saying. I think it was a very good workshop. Also, the day yesterday was interesting to give an overview where we stand, what we do, what the different objectives are, and then diving in those details. I'm very glad that from our organization we had quite a few people here which could participate and now can take it forward. Perhaps next time when you have it, we hope to have some other input and what had been achieved based on the results of today's meeting. So thank you very much for setting all of that up, building that up, and all the participants, all the presenters, a very good job. Thank you very much.
Thanks, Michael. So I suspect that we're going to do this again. And as mentioned, this was done as an initiative from the Open Digital Incubator. So just a few more words about that. You heard already quite a bit about it, but the purpose of this initiative is to implement the technical services following the specifications that are made by the relevant international organizations, mostly IALA, also IHO is coming along, and hopefully probably others in the future, support each other in the process of this development, lower the barrier for making these implementations, like developing something like the Secom library that we've heard about and the language binding repository, and test the interoperability of the implemented services that we've also seen, and provide feedback to the standardizing organization. So these are the overall purpose of the Open Digital Incubator. And everybody is cordially invited to join, maybe in particular some of the future service consumers, because as Ramin pointed out, this has been a little bit driven by the service provider and the shore side. So hopefully we can get more consumers involved in the future. We have a lot of organizations already actively involved here. There are more than these, but quite a few organizations that are working in this digital incubator. We are working with all the different services we have heard about. In the future, we'll have even more services. One we haven't talked about yet, but which has been agreed to be defined is underkeel clearance, and there will probably be more in the future. All the ones that have been talked about so far, the designs have been based on Secom, but that could be expanded in the future. There would be possibly other services based on different technologies, possibly the MMS, that may be playing a bigger role in the future. How to join, you ask? Well, we have a very complicated process of joining the digital incubator, and that is by sending an email to me. There's no actual membership formula or something like this with the MCP consortium. This is a very, very agile and informal collaboration we have. So just send me an email and you will be signed up. We are basically working by having bi-weekly Zoom meetings, and we have a Dropbox for sharing files. We have a mailing list and a Slack channel. So that's basically how we work. Sumbe, you want to say something? I think, yeah.
Okay, thank you.
Okay, yeah.
Because I didn't know how to raise my hand on the screen, but you show my screen. Thank you so much for having this very useful technical seminar. This seminar is timely, very good, because the IMO is going to establish some kind of the standard of regarding the Secom communication framework. Maybe within the 1 or 2 years, I expect within the 1 year, IMO can make the standardization of Secom communication framework. So anyway, the Korea side will make every effort to provide some kind of reference to move forward in establishing the standard of Secom based on our experience operating the e-navigation services based on the MCP. So it will be very good. Also, as the CEO of Korea Maritime Cooperation Center, I will also fully support for your efforts to facilitate this kind of communication before establishing the standard of Secom communication. And taking opportunity this, I want to thank and hello to Michael Bogman. Thank you so much. Thank you, Thomas.
Thank you, Sumbe. And I think that's it. Thank you for Nikos for chairing the sessions today. Thank you to all the presenters. Thank you for everybody participating. And information from the seminar will be available on the website. And this is not the last you've heard from the digital incubator. Thank you very much, everyone.
Bye-bye.
Thank you. It's very interesting.
Thank you.
Bye. Thank you.
Thank you. Bye-bye.